Well, like I said, today we're here at the semi-annual Calculus 2 review session, and I'm taking charge of the Calc 2 review session as my wife is taking charge of the Calc 1 review session. So in case you guys don't know, I'm Dr. John R. Taylor. Most of you guys are in my class, but a few of you guys have other professors. So we're going to be covering the spring 2017 exam. But I was asked by all the professors to issue this proclamation, as it were. Number one, after the exam, do not email your professor, do not call your professor, do not harass your professor. We do not have your grades. And in terms of your grades, the official rule of the university is once you're done with the final exam, grades are done. At this point, we're sitting there trying to actually get the grade exams graded and stuff. And I told you guys in my class that typically on Monday, weather permitting, we will have the grading party. We grade all the final exams, and it takes a couple of days for all of us to get our information in. So honestly, it will not be until Wednesday at the earliest that we actually have exam information that we put up. You guys will know when we have the exams done is when you see them automatically uploaded to the Canvas site. So, but even then, no, don't email us about grades. Don't call us about grades. We're not allowed to talk about grades with any students online or over the phone or anything. It has to be in person, one-on-one. For my class, I will give a particular time that I will be back in my office if you wanted to go look at your exam or something like that. But like I said, at this point, and especially with the exam being worth 30% of your grade, and with my class, that I allow the final exam to replace your lowest test grade based upon your attendance. You've got to have 2 or fewer absences. All of a sudden, your grades are going to change dramatically. So just don't sit there and just stare at the computer waiting for stuff to show up. Go get your other studies done and things like that. Things will automatically take place. Also, there are lots of things that will be going on, and I probably will turn off the grade book for a while I'm uploading a bunch of stuff. So don't freak out about that either. Don't worry. Things will be taken care of. But then all of a sudden, boom, it'll pop up and all your grades are there. But like I said, don't go going after your professor and then keep harassing about, grades done yet, grades done yet? You sound like my 4-year-old. No, no, they're not done yet. They'll probably by Wednesday or so. Again, weather permitting. If we have a wonderful snowstorm, who knows? It may be January by the time we get these things graded. Who knows? But there you go. But so make the official announcement there. All right. Now, for my class, where is your exam located at? First off, when is your exam, in case you didn't know? Tomorrow. That'll be Friday, Pearl Harbor Day, December 7th. Where is your exam going to be for my class? Magnary, 120? No, 125. You're in 125. Calc 1 is in 124. My Calc 2 class is in 125. Read your front page of your website. I mean, it's up there. It's been there for like 2 weeks now. It's still up there. Magnary 125, okay? Also, I have the test 4 material being passed out to you guys. It's coming around here. I've got Greg and Joseph getting together, and they're organizing the stuff to be passed out. So look for that while I'm going over this thing. So if you're not in my class, don't worry about it. But my class, and by the way, the final exam's at 5:30, but what time do you got to be at the exam? Right about 5 o'clock. Go ahead and get your seat, get yourself set up, and because we're going to be passing out a bunch of stuff, that you got to fill out the OpScan sheet, because right at 5:30 is when you open the test booklet and start taking the exam. So this was the spring 2017 exam. And so first things first, you get part 1. You've already filled out your OpScan sheet. They say open the test booklet. Remember, part 1 is a no calculator section, okay? So you have to put your calculators away. It'll be under your seat away. Do not bring your cell phones. You got to make sure your cell phones are off. You got to make sure you don't have any iWatches or anything like that. You're not allowed to have anything plugged into your ears. You can't have your tunes on while you're taking the exam. It is you have to classic exam. And don't forget to bring your student ID. You have to have your student ID, and you're going to be putting your 800 number on everything on the final exam. All right. So right now, let's say it's 5:30. They say open the test book. This is part 1, no calculator. Now, what do you think they're going to hit you hardest on in terms of this exam? integrals. Let's take a look. Ah, here we go. Number one, what are we supposed to do? Integrate. However, just because we don't have a calculator doesn't mean that you're not going to have to calculate some or other, but it'll be easy numbers. Let's say, for example, take a look at this guy, and I'll blow this one up so you guys can see it more in the back there. All right? It says this. An integral from 1 to 2 of 3x squared dx is, well, this would be equal to, 3 is a constant, leave it alone. The integral x squared is x cubed over 3, evaluated from 1 to 2. The 3's cancel, so this is x squared evaluated from 1 to 2. Fundamental theorem of calculus, plug in top minus plug in bottom. 2 squared minus 1 squared. 2 squared is 4, minus 1 is 3. Wait a minute, oh, excuse me, it's cubed. I lost my little cube there. It's too early in the morning. Cubed. Oh, 2 cubed is what? 8, even better. 8 minus 1 is 7, and the answer is 7. Now, usually, not always, but usually the first problem they give you in the exam is kind of a gimme. Here you go. You should know how to do this. Make yourself good about the exam. We already got 100 on this exam. Don't worry, we'll get you later. So let's try the next one. The integral from 1 to 4 of 1 over x dx. Now, when I'm doing these reviews, I can skip a lot of steps, but I'm not going to. I'm going to treat every problem up here as if it was a free response question. So if this does show up on a free response, this is the work I expect to see. All right, so 1 over x dx, we'll integrate 1 over x is the natural log of the absolute value of x, evaluated from 1 to 4. Fundamental theorem, plug in top minus plug in bottom. Natural log of 4 minus the natural log of 1. However, what's the natural log of 1? Something you should know from high school. That's 0, so it makes the answer the natural log of 4. So the answer is E. Does that make sense? Again, they start you out pretty good, but it doesn't take long for them to, all right, how are you going to integrate this guy? The integral of x times the cube root of x squared minus 1 dx. Well, first off, clean them up. You're on the right track, absolutely U-substitution, but clean them up. I don't do cube roots. What's a cube root? To the 1/3 power dx. So clean them up, and then, because it's not a form I have memorized, the number one technique of integration is U-substitution. So let u equal to inside x squared minus 1. That makes du the derivative 2x dx. I see an x dx in the problem, so I know I'm on the right track. I can always move the constant. 1/2 of du equals x dx in my substitution. So when I substitute, this becomes u to the 1/3, but the x dx gets replaced with a half du. You put the constant in the front, and the du goes in the back. Classic rules of integration here. Add 1 over add 1. So this gives you equal to 1/2. 1/3 plus 1 would be u to the 4/3 over 4/3. No bounds on this stuff, so plus c, but I'm going to clean it up. So when I divide, I invert and multiply. So this ends up becoming 1/2 times 3/4 u to the 4/3 plus c. And nothing cancels. This is what, 3/8. And replace u. What was u equal to? X squared minus 1 to the 4/3 plus c. And so which one is this one? And double check each one and take your time on making sure that all the parts are there. It looks like answer A. So it didn't take them long. A couple of basic rules you're supposed to have memorized. The next one was U-substitution. What about this guy? Now, this kind of a problem, at this point in your career, you should recognize it. It's the integral of x times the sine of x dx. We've done this thing about 14 times in this class. So recognize the style of problem it is. This is not a U-substitution problem because there's nothing for me to let u equal to where du is going to be in the problem. But anytime you got that x times a sine x or x times cosine of x, this is a classic integration by parts. So the first thing you do with integration by parts is write down the formula. Integral of u dv equals uv minus the integral of v du. As you do these exams, and this should not be the only exam you do, you should have a separate sheet of paper as you're working through these exams, and every time you have a formula that I need to memorize, I make sure I go write it down, something to review later. All right, integration by parts. Now, traditionally, I'm going to let u equal to the part I want to get rid of, and I get rid of things through the derivative. And if that x wasn't there, I could actually integrate the thing. So I'm going to let u equal x. That would make du equal to the derivative of x is 1 dx. That makes the dv equal to the sine of x dx. And so when I integrate sine, what's the integral of sine? Negative cosine of x. Make sure you know your derivative rules and your integral rules, and don't get the two confused, left brain, right brain. The integral of sine of x dx is negative cosine of x. Now I plug it into my formula, u times v, which would be x times negative cosine of x, minus the integral of v, negative cosine of x, du, which is dx. And I wanted you to see the literal plugging it in into the parts. Okay? And so I'm going to clean this up. This will be negative x cosine of x, so minus makes it plus the integral of the cosine of x dx. So this is negative x cosine of x plus, what's the integral of cosine of x dx? Sine of x. And no bounds on this stuff, plus c. And so you got your answer, but of course they didn't write it exactly like that. It's a minus x cosine of x and the positive sine of x. So the answer on this one is B. Take your time on bubbling your answers. Remind you, you got 3 hours on this exam. But this first part must be done within the first hour of the exam. In the first hour exam, no one's allowed to have their calculator. Okay, so problem number 5 here is this. Understanding the concept of integrals. No calculator here. The integral from 0 to 2 of f of x dx, where the graph of f of x is given below. When you integrate, you have learned personally by me, when you integrate something or other and you got a picture, what are you actually finding? Area under the curve. Integral is area under the curve when you got bounds, 0 to 2. So between 0 and 2, we're talking about this integral between 0 and 2 of f of x dx is equal to this area under the curve between x equals 0 and x equals 2. Now, so first off, I'm only looking at this section of area. Don't let this part confuse you over here. So I'm going to shade this part. That's all I need to know. Now, what am I going to do to figure this thing out? Well, personally, I'm going to do this, subdivide this thing into particular regions and stuff. So I'm going to turn it into pretty much 3 different little areas. I'm going to have this area here, and I'm going to do this area right here. So I'm going to label these guys. I'm going to call this area 1, area 2, and area 3. So area 1 is a triangle. What's the area of a triangle? 1/2 base times height. But in this problem, the base is 1, the height is 2. So this will be 1/2, 2 times 2. Plus, I'll clean that up later. My area 2 is another triangle, which is 1/2 base times height. But its base is 1 and its height is 1. So this will be plus 1/2, 1 times 1. Plus area 3 is a square. Its base is 1, its height is 1, so area square is base times height, which will be plus 1 times 1. So now I'm going to put my numbers together. Again, don't have a calculator, but I don't need one. 2 times 2 is 4. 1/2 of that is 2. 1 times 1 times 1/2 is 1/2. Plus 1 times 1 is 1. 1 plus 2 is 3, and 1/2, it's 3.5. Wait a minute, what did I screw up here? A1, base is 1. Oh, the base is 1. Thank you. The base is 1 there. I'm just having a bad day. 1/2, 1 times 2, that makes it 1. So let's try this again. 1 plus 1/2 plus 1, that makes it 2.5. Watch the careless errors, because I make them up here. So it's 2.5, because that's 1 right there. The base is 1. The height is 2. So don't make careless errors. 2.5, the answer is C. Does that make sense, though? Questions? All right, look at the next one. F of t is equal to the integral from 7 to t squared minus 1 times the square root of x cubed plus 1 dx. Determine f prime of 1. This is one of those other fundamental theorem of calculus. You're taking the derivative of an integral. And remember, when you take the derivative of an integral, they pretty much cancel and you get the function back. But because we have something other than just a plain old single t variable up here, we're going to have to use the chain rule version of this thing. So to take the derivative of t, you're going to take the derivative with respect to t of the integral from 7 to t squared minus 1 of the square root of x cubed plus 1 dx. Okay? Now, the derivative of the integral cancel. That's the whole goal. So I'm going to replace the x with t squared minus 1. So this will be the square root of t squared minus 1, but that's being cubed, plus 1. But then times, you got to use the chain rule version of this guy. Because anything other than just the single variable plugged in, you got to do times the derivative of the inside. It comes from the chain rule. Derivative of the outside, inside stays the same time derivative of the inside. So derivative of the outside basically cancels with the integral part, but then you got to do times the derivative of what you plugged in. What is the derivative of t squared minus 1? Derivative now, calc 1, 2t. So this cleans up to become 2t times the square root of t squared minus 1 cubed plus 1. But we've got one more hoop to jump through here. They didn't want you to find f prime of t. They wanted you to find f prime of 1. So what am I going to do? Plug in 1. 2 times 1 times the square root of 1 squared minus 1 cubed plus 1. And again, just be careful. Don't rush through it too quickly. Don't make careless errors on the algebra. 1 squared is 1, minus 1 is, that's a 1 there. 1 squared is 1, minus 1 is 0, cubed is 0, plus 1 is 1. So, and this is, excuse me, this is t here, plugging in. So this is 0. So this is 2 times the square root of 1. Square root of 1 is 1. 2, I get the answer, is 2. Just be careful when you're plugging in your numbers, and because we don't have a calculator on this stuff. Does that make sense? So don't forget the other fundamental theorem of calculus. They're going to quiz you on that one as well. The derivative of an integral doesn't go anywhere. Now here's one that tends to give my students a bunch of fits, because they typically hate this one. The famous, okay, here's a Riemann sum, rewrite it as an integral. Just to remind you guys the formula, because I'm trying to review, so I'm going a little bit deeper than I would just hey, the answer is B up here, or whatever the case may be. So here's the deal. In terms of Riemann sum, the integral from a to b of f of x dx is equal to the limit as n approaches infinity of the sum as I goes from 1 to n of f of xi times delta x, where, these are your formulas, delta x is equal to b minus a divided by n, and the way I look at that, it's a number divided by n, and your xi is equal to a plus I times delta x. Okay? So this one, they tried to mess you up. So we've got to figure out what is it, given this part here, what's it going to look like as an integral? Well, they gave me the limit as n approaches infinity of I squared over n cubed. First off, I know any Riemann sum has to have a times delta x, either in the back or the front. But you remember, a delta x is a number divided by n. You'll notice that your powers are not the same. The I is being squared, but the n is being cubed. So I'm going to pull off one of my n's to make it look like this. I got to have a number times a number over n. So this is going to be, and there's a sum right there. So this is equal to the limit as n approaches infinity of the sum as I goes from 1 to n of I squared over n squared times 1 over n. Okay? I pulled off one of my n's. So this turns into the limit as n approaches infinity of the sum as I goes from 1 to infinity. I squared over n squared is I divided by n squared times 1 over n. That right there tells me my delta x is equal to, which is b minus a over n, is equal to 1 over n. That tells me that b minus a has to be equal to 1. So in terms of my integral, the difference of my integrals has to be equal to 1. Well, that doesn't really help me out in this problem, because 1 to 2, 1 to 2, 0 to 1, 0 to 1, 0 to 1, they all differ by 1. Now, I now got to figure out, so this is going to be my delta x part, and the delta x actually turns into that dx, if you will. Now, this has got to be the functional part, the I over n squared. So I've got to turn this into a part of a function. xi is equal to a plus I times delta x. Delta x is 1 over n. So that means xi is going to be a plus I over n. I just got to figure out what the a is. The a is either going to be 0 or 1 based upon my answers. I am using my answers to guide me on this thing. And if I let a equal 1, xi, if a equals 1, this will be 1 plus I over n replaces the x. Do you see a 1 plus I over n in this problem anywhere? I see an I over n. I don't see a 1 plus I over n. So this is not the way to go. So I would do the other one. If a equals 0, then your xi would be 0 plus I over n, which is I over n. So I can replace I over n with x. So when I do that, this part becomes the integral. The I over n becomes an x squared. That 1 over n is my delta x, which turns into the dx. And if a equals 0, what does b have to be if a is 0? So b minus 0 has got to be equal to 1. That implies b equals 1. So it's from 0 to 1 of x squared. 0 to 1 of x squared. The answer is b. And honestly, you're playing detective work in terms of these answers. There's only one of these guys going to work for you. Yeah? Which section? Over here? So, and the trick was, once I discovered the delta x, which is 1 over n, I plug it into the xi form, which is a plus I times delta x, gives you a plus I over n. You're going to replace your a plus I over n with x. So you had two choices on this one, and the reason why you had two choices was your answer set. Either a was going to be 1 or a was going to be 0. So I'm using both of those to judge, but when a equals 1, none of those answers work because I got to have in my problem a 1 plus I over n to replace with the x. And so it's not there. So a had to be 0. When a was 0, it actually matches perfectly to this answer b. The next one's pretty simple here because we just had a test on this one. The sequence an is equal to 2 plus n cubed over 1 minus 2n cubed. And you're supposed to tell if it converges or diverges. How do you tell if a sequence converges or diverges? What do? You take the limit as n approaches infinity of this an. That'll be the limit as n approaches infinity of 2 plus n cubed over 1 minus 2n cubed. I want to remind you that you are in Calculus 2. So if you plug in infinity, you get infinity over infinity. Officially infinity over negative infinity, but whatever. You can use L'Hopital's rule a couple of times on this thing if you need to, but you shouldn't have to. You should know when I'm taking the limit as n approaches infinity of a polynomial over a polynomial, the commanding term is the degree term. And I happen to notice that the cube on top and the cube on the bottom are the same, so the degree 3. Does that make sense? And when the degree of the top is equal to the degree of the bottom, the degree of the numerator equals the degree of the denominator, then the limit's going to be the ratio of the leading coefficients, which is what? 1 over, watch your signs, negative 2, which makes it what? Negative 1/2. Watch the signs. That's where most people mess this problem up on the original exam. They went too fast. I saw the 1 over the 2, and they went 1/2. Nope, that's a negative sign there. The answer is E. Does that make sense? Again, you can also do L'Hopital's rule if you like to fill in that problem. On this problem, you're supposed to, once again, find the area of the region bounded by the curve y equals e to the 5x and the x-axis. Well, you should recognize, even though I don't have a calculator, what e to the 5x looks like. It's a classic e to the x look. E to the 0 is 1, and it's an exponential growth kind of problem. We're integrating it between 0 and 1, and we're trying to find the area between this equation, y equals e to the 5x, and the x-axis, which is this particular area right here. Area is equal to the integral of officially top minus bottom. This will be e to the 5x minus the bottom is x-axis, which is y equals 0, dx. Pretty much all I got to do is just integrate the function over my bounds from 0 to 1. This is the integral from 0 to 1 of e to the 5x dx. Now, this is a rule. You can use U-substitution if you want to, but this is one of the rules you're supposed to have memorized, the famous e to the kx. The integral e to the kx dx is 1 over k e to the kx. So in this problem, it would be what? 1 over 5 e to the 5x. Does that make sense? U-substitution in your head, if you will, but that's a rule you're actually supposed to have memorized. Evaluated from 0 to 1. Fundamental theorem, plug in top minus plug in bottom. That'll be 1/5 e to the 5 times 1 minus 1/5 e to the 5 times 0. 5 times 0 is 0. E to the 0 is 1. So this gives you 1/5 times e to the 5 times 1 is 5 minus, that's 1, so factoring out the 1/5 makes it 1, makes the answer D. Does that make sense? This next one, okay? The integral of x to the 4th natural log of x squared dx. On this particular problem, anytime you're trying to integrate a natural log, first, try U-substitution. Let U be something and see if du is going to be in the problem. Well, if I let u equal to like the natural log of x squared, the derivative of that is going to be 1 over x squared times derivative of the inside, which is 2x, which pretty much makes it 2 over x. And I don't see that in the problem. I don't see any over x's at all. So U-substitution is not going to work on this thing. And 9 times out of 10, when I want to integrate a natural log, I'm going to use what technique? Integration by parts. Remember that. So how many times we drilled this one into your head. Integration by parts. Integration by parts, the formula is the integral of u dv equals uv minus the integral of v du. And when it comes to integration by parts, when you're trying to integrate the natural log function with times something else, you always let u equal to the natural log. In this case, the natural log of x squared. That means the derivative is going to be 1 over x squared times derivative of the inside chain rule times 2x. We'll clean that up, and that becomes pretty much 2 over x if you think about it. The dv is going to be the other part, which will be the x to the 4th dx. And when you integrate that, integral x to the 4th is x to the 5th over 5. Okay? So now I'm going to plug it into my formula. So this will be equal to u times v. U times v, that'll be the natural log of x squared times v, which is x to the 5th over 5, minus the integral of v, which is x to the 5th over 5, times du, which is times, du is 2 over x, got my little dx there, times dx, 2 over x dx. I'm going to clean this guy up. So this gives me, that makes it look better to write him as x to the 5th times the natural log of x squared over 5, minus 2/5 is a constant. I'm going to pull it out front, times the integral of, remember, clean this up. What's x to the 5th divided by x? X to the 4th dx. That's where most people will mess it up, that when you're doing integration by parts, you have to clean up the secondary integral when you've got those two functions. We've got a bunch of stuff canceling them out. If I can get the autofocus working on this thing. There we go, a little bit better. Okay? So now, I've just got to integrate this latter part right here. So this ends up becoming x to the 5th over 5 times the natural log of x squared minus 2/5. What's the integral x to the 4th? That's x to the 5th over 5 plus c there. And so the last little thing, and I'm kind of running into the next problem over here, but that's all right. This will end up being x to the 5th over 5 times the natural log of x squared minus 2 over 25 x to the 5th plus c. Which means the answer is going to be, which one of these guys? Let's see here. Minus 2 over 25. There's only one with a minus here. The answer is D. Does that make sense? Questions? Well, here's another one. They didn't ask you to integrate it. That will come in the next one. But they gave you, here's the deal here. Now, pay attention to this one because you can save some time on this one. It says this. You got the function, use partial fractions to find the value of b. Find the value of b. You've got 2x squared minus 3x plus 3 divided by x times x minus 1 squared. And they went ahead and broke it down for you because he had to use the power rule. They don't always give that to you. Make sure you know how to use the power rule. When you've got that factor of x minus 1 squared, that means you're going to have the factor of x minus 1 squared as well as what a factor of that, which is x minus 1. Since these guys are both cut from the same factor of x minus 1, and that's a degree 1, the numerator has to be a degree less, that's going to be a constant. So they're always going to have constants. It's called your power rule for these powers of a factor here. But they gave this one to you, so you're supposed to find b. The first thing you need to do is take this equation, 2x squared minus 3x plus 3 over x times x minus 1 squared, which is equal to this a over x, plus b over x minus 1, plus c over x minus 1 squared. And you're going to multiply by your common denominator, which is the x times x minus 1 squared. When I do over here, it will cancel and leave me with 2x squared minus 3x plus 3 equals, here the x's cancel, so it'll be a times, x is cancel, x minus 1 squared, plus b times, one of the x minus 1 squared, she cancels the x with the x minus 1, but you're left with x times one of the x minus 1s, plus c times, here the x minus 1 squareds completely cancel, c times x. Now, you want to find b. The problem with b is this. Typically, I taught our students to do the annihilator method. The annihilator method is, you can use linear algebra on this thing and do systems of equations, but the easiest way is just pick some numbers, and not just pick any numbers. Pick numbers that make zeros, the annihilators, kills off terms. So there are 3 letters to solve for. I need 3 numbers. What x numbers do you suggest I use? 1's a good choice. What's another one? 0. And here's my problem. There are 3 numbers that kill this stuff off. I need 3 numbers, but there's only 2 numbers that kill this stuff off. X is 1, we'll make a term 0. X is 0 works, but I got another number. I need one more number. The problem is I'm ran out of annihilators on this thing. So it doesn't matter which number you use. I would suggest like x equals 2 or something simple to plug in. Doesn't matter. You can use x equals -1 or something like that. Now, you want nice numbers because remember, we have no calculators. So here we go. Plug in x is 1. 1 squared is 1 times 2 is 2. And I'll just write it like this. It'll be 2. 3 times 1 is 3 minus 3 plus 3. That would be equal to a times, plugging in 1 here, times 0, plus b times, plugging in 1 here, makes it 0, plus c times 1. These guys go away, and the 3's go away, so 2 is equal to c. So at x equals 1, and plugging it in, x equals 1 will kill off this term and kill off this term with the x minus 1s. That makes c, and plugging in 1 on this side gives me just 2, so c equals 2. Now I'm going to plug in 0. Plugging in 0 gives me pretty much 3 is equal to a times -1 squared plus b, 0 times x minus 1 is 0, plus c times 0. These guys go away. -1 squared is 1, so 3 equals a. A equals 3 is my other letter. Now I'm going to plug in 2. This one's going to take a little bit more work. All right, so plugging in 2, this will be, putting them over here, 2 times 2 squared minus 3 times 2 plus 3. That's going to be equal to a times 2 minus 1 squared plus b times 2 minus 1, ran out of room there, plus c times 2. Well, 2 squared is 4 times 2 is 8, minus 3 times 2 is 6, plus 3. Just watch the arithmetic. So I get 8 minus 6, which is 2, plus 3 is 5, is equal to 2 minus 1 is 1 squared is 1a, plus 2 minus 1 is 1 times 2 is 2, 2b, plus 2c. Okay? And so 2 times c. Now, we know what a and c are. A is 3 and b and c is 2. So this will be 5 equals a, which is 3, plus 2 times b, plus 2 times c, which is 2. So, clean it up. This will be 5 equals 2 plus 3 is 4. 4 plus 3 is 7 plus 2b. I'm going to subtract 7 because I'm not going to skip any steps with you guys. -2 equals 2b divided by 2, and that gives me b is equal to -1. So what's the value of b? It's -1. Does that make sense? Notice this one took me a little bit more time to do, but that's okay. You got 3 hours. It's all right. Okay. You got 1 hour to complete part 1. Look at number 12 here. And I'm going to do this because I used a lot of room on this particular problem here. Look at problem number 1. You're going to integrate. Pay attention to this one. You're going to integrate 1 over x squared minus 4x plus 5 dx. Well, U-substitution is just not going to work for you on here because you have to let u equal the denominator, x squared plus minus 4x plus 5. du is 2x minus 4 dx. You can factor out the 2, but I still don't see an x minus 2 in this problem. So U-substitution is not going to work. You should have also realized the fact that, look at that denominator, x squared minus 4x plus 5. It happens to factor. So I've got 1 over x squared minus 4x plus 5. That factors into, it'll be x and x. What times what is 5? That adds up to be 4. Okay? Well, wait a minute. 5, it doesn't factor. Because what times what is 5? That adds up to be 4. Well, it's going to be 5 and 1, right? But that adds up to be 6 because it's a plus. It doesn't factor. What am I going to do? I've got a term that, quote, doesn't factor. Do you guys remember? It's a quadratic. If the quadratic factors, then I can use partial fractions. If the quadratic doesn't factor, what can you do? Uh-oh, I heard the words. It's awful words for some of you people. What is it? Complete the square. Yep, they threw this one at you. Yay. Okay. Complete the square. How do you complete the square? You got to make sure the coefficient in front of the x squared is a 1. If it is not, factor it out of all the x terms. So step 1 is you put all the x terms together, x squared minus 4x, and just kind of push back that plus 5. You make sure the coefficient in front of the x squared is a 1. If it's not, you factor out of the x's. The second step, to complete the square, you take 1/2 the b term and you square it. That gives you the magic number to complete the square. Your b term in this problem is -4. So what's half of -4? Half of -4 is -2 squared. What's half of -4? -2 squared is 4. The magic number to complete the square on this thing is 4. So I'm going to add 4. But whatever I giveth, I have to taketh away to maintain equality. Then I'm going to subtract 4 to maintain equality. This would end up becoming 1 over, this is going to factor into x minus 2 squared plus 5 minus 4 is 1. So that's what it turns into, 1 over x minus 2 squared plus 1. So this turns into the integral of 1 over x minus 2 squared plus 1 dx. Is this a formula that you memorized? I hope so, but let me write him over here in case you didn't. The integral of 1 over u squared plus a squared du, this is one of your favorite formulas you're supposed to have memorized. What's this guy equal to? 1 over a arctangent of u over a plus c. So again, as you go through these final exams, go back and remember a lot of these forms you're supposed to have memorized. So in this particular problem, the u squared is going to be x minus 2 squared. That makes u equal to x minus 2, and that makes du equal to dx. The a squared is equal to 1, making a equal to 1. So this completely substitutes into 1 over u squared plus a squared du, which is 1 over a arctangent of u over a plus c, which is equal to 1 over a is 1, arctangent of u, which is x minus 2 over a, which is 1, plus c. So cleaning it up, that gives you the arctangent of x minus 2 plus c, which means the answer is D. Does that make sense? Did I lose you guys anywhere? Where did I lose you at? Formula you need to have memorized. Arctangent. You have to complete the square off this guy. X squared minus 4x plus 5. To complete the square, you've got to take half the b term and square it. Half of -4 is -2 squared. -2 squared is 4. So the magic number to complete the square is 4. So with the x's, you add 4, but with the constant, you take away 4. That maintains equality. This first part's going to factor plus 1, and then it becomes a classic U substitution with this arctangent formula that you have memorized. Does that make sense? All right, let's look at the next one. Well, there's one. You saw him before on my test. You saw him on the test review. Here it is again. The geometric series is 6 minus 4 plus 8 thirds minus 16 ninths plus 32 over 27 minus ... And they're telling you it's a geometric series, but you should recognize this because a geometric series, to go from one term to the next term, you got to multiply by the same fraction. What do I need to multiply by 6 to get a negative 4? You need to multiply by a negative, let's see, to get negative 4. I want to multiply by what, negative 2/3? Okay, now I'm going to double check. What do I need to multiply by negative 4 to get 8/3? I'm going to multiply by negative 2/3. Negative 4 times negative 2 is positive 8/3. What do I need to multiply by 8/3 to get a negative 16/3? I multiply by negative 2/3. Negative 8 times the negative 2 is negative 16. 3 times 3 is 9, ... This tells me my R is negative 2/3. R is the number or the ratio you need to multiply the first term by to get to the second term. And it should be the same number that you have to multiply the second term to get to the third term, ... And A is always the first number in your lineup that you started multiplying these numbers by. So in this case, A would be equal to 6. And you notice that it's a geometric series. So the absolute value of R, which is the absolute value of negative 2/3, which is equal to 2/3, is less than 1. So we know this thing converges to the formula A over 1 minus R. So this would be equal to, plugging in A is 6 over 1 minus R, negative 2/3. Again, no calculator on this thing, so we're going to have to sit there and do some arithmetic. This will be 6 over, a minus is a plus, 1 plus 2/3. 1 plus 2/3, 1 is 3/3, so this will be 6 over 5/3. And when you divide by a fraction, you invert and multiply, that'll be 6 times 3 over 5. And so that gives you 3 times 6 is 18. I got 18/5. This is what it converges to, 18/5. The answer is A. Just be careful. It's not hard arithmetic they're going to make you do, but they are going to make you crunch a few basic numbers here, and fractions are included in that. Does that make sense? All right? This one messed up a lot of people on the exam because they weren't paying attention. We want you to integrate from negative 1 to 2 of 1 over x squared dx. Look at the function. It is 1 over x squared. This function doesn't exist everywhere. It has a problem where? Where's its problem point? 1 over x squared. What value of x makes this thing have a problem? 0, because you can't divide by 0. And you notice your problem point 0. So as I integrate this thing from negative 1 to 2 of 1 over x squared dx, my problem point, and I'll label them as such, problem point is x equals 0, is right in the middle of your integrand from negative 1 to 2. So when you integrate over a problem point, we have a special name for these kind of integrals. It is called an improper integral. So to make this guy into a, so just to remind yourself, when you're studying, this is an improper integral. So, being an improper integral, I'm going to break this guy up into the integral from negative 1 to 0, and that'll be from below, of 1 over x squared dx, plus the integral, pick it up again, but it'll be 0 on the other side, plus side, up to 2 of 1 over x squared dx. This problem is just turned into two problems. Okay? Now, again, when you're doing multiple choice questions, you guys can cut through some, don't write as detailed as I'm writing it, but I'm also treating this guy as if it was a free response. So I'm going to go out of my way to discuss, how you should write it up in case this problem was a free response question. So it's improper, so you pick your favorite letter, take the limit, and I'm going to pick A, approaches 0 from below of the integral from negative 1 to A. I'm going to clean this up. This will be x to negative 2 dx, plus, pick another letter, the limit as, let's say, B, approaches 0 from the plus side of the integral from B to 2 of x to negative 2 dx. Now here's the deal. For this integral to converge to a particular number, this integral, the first half has to converge to a number, plus the second half has to converge to a number. If just one of these two integrals diverges, the whole answer is divergent. If part of it blows up, the whole thing's got to blow up. So, I'm going to start with one of them and see if it converges or diverges. So if this guy converges, I'm going to get its number, then I go integrate this guy. If that guy converges, then the answer is, I'll just add those two answers together. But if just one of these guys diverges, blows up to infinity or whatever, then the answer is diverges. So here we go. I'm going to do this guy here. So I'm going to integrate. So this is equal to the limit as a approaches 0 from below of integrate x to the -2, add 1 over add 1, x to -1 over -1, evaluated from -1 to a. Cleaning them up, this is the limit as a approaches 0 from below of -1 over x, evaluated from -1 to a. Fundamental theorem of calculus, plug in top minus plug in bottom. This will be -1 over a minus -1 over -1. Plug in top minus plug in bottom. Clean them up. This is the limit as a approaches 0 from below of -1 over a minus -1 divided by -1 is 1. Now, plug in a. A is going to 0 from below. So this is equal to -1 over 0 from below minus 1. Things you need to know. This guy, what is 1 divided by 0? 1 divided by 0 from below is actually negative infinity. 1 divided by 0 from above is positive infinity. And just to remind you also that 1 divided by infinity is actually 0, but this is on the reverse. 1 over 0 on the negative side is negative infinity. 1 over 0 on the plus side is positive infinity. This one's going to be, watch your signs, this will be negative. This part right here is negative infinity minus 1. Negative infinity is infinity minus what? Makes the answer infinity. This integral actually diverges. It blows up. Does that make sense? And actually, I don't even care what this integral does. If just part of this thing diverges, the whole thing has to diverge. The only way this improper integral, this original improper integral, converges is if both sides converge. So the answer to this problem is E. It diverges. Classic, what I called a type 2 improper integral from class. Does that make sense? Okay? But remember your improper integrals. But you understand what most people did on this problem during the exam? This is the kind of stuff that catches people. They weren't paying attention. They just said this is x to the -2, integrate that, x to -1 over -1. They plugged in top, minus plugged in bottom. And trust me, that answer is up there somewhere, and people just circled the crap out of that answer, and they got it big time wrong. Okay? Pay attention. If you integrate over something that doesn't exist, that's called an improper integral, and this is the proper technique of how to write it up. All right? Let's take a look at this guy here. Here's another one. A formula you're supposed to have memorized. It is the integral from 0 to infinity of 1 over x1 plus x squared dx. Well, first off, this is an improper integral again, but this is what I call a type 1 improper integral. Pretty obvious. Got a big old infinity on the bound. So to make it proper, and again, I'm writing this stuff up as if it was a free response question. You're going to take the limit, pick your favorite letter, a approaches infinity of the integral from 0 to a of 1 over 1 plus x squared dx. Next thing you got to do is you got to integrate it. But this integral is something you should have memorized. What is the integral of 1 over 1 plus x squared? Arctangent, tangent inverse. So this would be the limit, get my limit proper right, limit as a approaches infinity of the arctangent of x, that's what that integral is, pure memorization, evaluated from 0 to a. According to the fundamental theorems, you plug in top minus plug in bottom. So this is the limit as a approaches infinity of arctangent of a minus the arctangent of 0. Now let's talk about some trig stuff you're supposed to know. What is the arctangent or tangent inverse of 0? 0. And plugging in infinity, this will be the arctangent of a, taking the limit as a approaches infinity, of infinity. So this is arctangent of infinity minus 0. But this is one of your limit laws. What is the arctangent of infinity? The limit as a approaches infinity of the arctangent of a is the arctangent of infinity, which is pi halves. 90 degrees for you degree people, but we're always in radians because we're real math people. So it is pi halves, okay? So this is going to be equal to pi halves minus 0. So I got a number. And when an improper integral, when we have a number, we would say it converges to pi halves. So the answer to this problem, as I go back and look at my answer, converges to pi halves, is answer C. Does that make sense? And if you look at your clocks, I got started a little late because we discussed a little housekeeping stuff about the exam and stuff like that. Then I got started, but it took me about, with explanation and detailed, it took me about 40 minutes. That's average for most people doing part 1. You've got 1 hour to do part number 1, okay? But now, I'm going to go ahead and turn in part number 1, and then I'm going to give you guys in my class, every professor is different how they do it, but I'm going to go ahead and give you part number 2 with another OBSCAN sheet. You have to turn in your OBSCAN sheet and part number 1, and then I'm going to give you part number 2, an OBSCAN sheet, and part number 3. But still, I got 20 minutes before I'm allowed to use a calculator. Am I going to sit there and fiddle my thumbs and kind of goof off and stuff? Lord, no. I can do most of this exam without a calculator. Okay? Sometimes I'll need one. And if I need one, well, I'll stop there where I need it and go on and just don't forget to go back and do the problem. So here's part number 2 with the calculator, but right now I'm not allowed to have a calculator yet. Okay? Oh, so here we go. Let's take a look at this first one. So this is where you're going to see more of your word problem-ish style stuff here. So here we go. Suppose that 20 newtons of force is required to stretch a spring from its natural length of 30 centimeters to 40 centimeters. How much work in joules is used to stretch a spring from 35 centimeters to 42 centimeters? All right, so it's a classic spring problem. Remember, you always have to zero out your natural length. So we got this wall right here, and here's my spring, all the way to this point right here, and it said it has a natural length, so I'm going to label it NL, natural length of 30 centimeters, and it took it to stretch it all the way out here to 40 centimeters. And it took 20 newtons of force. This is force, 20 newtons. Anytime we give you a spring problem, the first part of the paragraph of the spring problem is used to find K. This is your job in finding K. So now, first things first, you got to zero out your natural length. So 30 centimeters is actually 0 centimeters. That makes 40 centimeters how long? 10 centimeters. You subtract it out. This is 0. So 30 is 0. That makes 40 equal to 10 centimeters. The second thing is this. You got to convert it, because they want it in joules, which is a Newton meter. You got to convert it to meters. 10 centimeters is how much? Divide by 100, because there's 100 centimeters in a meter. That's going to be 0.1 meter. 0 centimeters is 0 meters. So it's pretty much from 0 meters to 0.1 meters. Does that make sense? And your formula is force equals Kx. This is your x, 0.1. So this is easy math. I don't need a calculator for this. So I got 20 is equal to K times 0.1. Solve for K. What am I going to do? I'm going to divide by 0.1 on both sides. And this is going to give me K is equal to, what's 20 divided by 0.1? 200. Well, that's not the answer, of course, but that's the part that I need. Because to actually find the work done, work is equal to the integral of Kx dx from A to B. That's the formula you need to know to calculate work on a spring problem. But the first thing you got to do on any kind of spring problem is to find that K. K is 200 in this problem. So now, here comes the question. How much work in joules is used to stretch a spring from 35 centimeters? So here we go again. Now we're going to take this thing over here to from 35 centimeters, and we're going to stretch it all the way out here to 42 centimeters. But remember, the natural length was 30 centimeters. You with me? This is 0 point there. So if 30 centimeters is 0, what does that make 35 centimeters? How far beyond the natural length is that? 5 centimeters. And how far beyond the natural length is 42 centimeters? From 30. 30 is your 0 point. Easy math. What is it? 12 centimeters. But then you got to convert it to meters. 5 centimeters is 0.05 meters because you divide by 100. And 12 centimeters is 0.12 meters because centimeters to meters you divide by 100. The nice thing about the metric system. So to get my problem, work is equal to the integral from 0.05 to 0.12 of k, which is 200x dx. Does that make sense? Now all I got to do is integrate this thing. And this is easy integral. 200's a constant, leave it alone. What's integral x to the first power dx? Add 1 over add 1. That's x squared divided by 2. And 2 goes into 200, 100 times x squared, evaluated from 0.05 to 0.12. So this is equal to 100 times 0.12 squared minus 100 times 0.05 squared. I'll blow this up for you guys to see over here in the corner. Okay? And so when you do this, this is going to be pretty much 100 times 0.12 squared minus 0.05 squared. And I know you're looking at this going, boy, I really need a calculator for this. Then great. Go on to the next problem until you are officially allowed to actually say everybody's allowed to have their calculator. And that doesn't occur until, remember, your exam starts at 5:30 until 6:30. No one's allowed to use their calculator until everybody has turned in part number 1. That's very important because we've had people caught cheating, and that's what we call in the math department, when they grab their calculator out before they're allowed to have their calculator, and they get their exams ripped up. Well, I was working on part number 2. I don't care. Until I give you the official word that the final exam, you're allowed to use the calculator in the final exam, that means everybody has turned in part number 1. Nobody gets to use it. But let's just assume, just because we're doing the review here on this thing, 0.12 squared is what? 0.144. Okay, so this is 100 times 0.144, but I'll just do it this way. 0.12 squared minus 100 times 0.05 squared. And I end up getting 1.19, and this would be either Newton meters or joules. And so there's my answer, calculating it out, which means the answer is E. Does that make sense? Questions? Classic problem, and remember your formulas. So as we go through these things, I'm trying to remind you of things you're supposed to have memorized for this exam. Okay? Next one says this. The integral of the cosine of the square root of x is equal to which of the following functions, following integrals, after the use of the appropriate U-substitution? Well, if I'm going to integrate the cosine of the square root of x dx, what would you let u equal to in U-substitution? The angle inside of the trig, of course. So that'll be the square root of x, which is x to the 1/2 power. Then you got to do du, the derivative. The derivative of x to the 1/2 is 1/2 x to the negative 1/2 dx. Clean them up. Du is equal to 1 over 2. X to the 1/2 is the square root of x, but with the negative exponent, it goes on the bottom, square root of x dx. Now remember, when you got a function left with your dx part, in terms of x, move it to the du side. So this means that 2 times the square root of x times du is equal to dx. I multiplied by 2 square roots of x on both sides. I moved it to the du side, but what is the square root of x? Also known as, the square root of x is the same thing as what? U. So this is 2u du equals dx. So when I do my substitution, just to show you, the integral of the cosine of the square root of x dx, When you substitute, this will be the integral of the cosine. The square root of x was u. Dx gets replaced with 2u du. That literal substitution aspect here. So when you clean this guy up, I pull the 2 out front because that's where my constants go. 2 times integral of u is still out front, and then you got the cosine of u du in the back. So this ends up becoming 2 times integral u cosine of u du, which is, which one of these guys? D. That's how you would do the u substitution on this problem. You got to let u equal the square root of x, which is x to 1/2. du is going to be 1/2 x to negative 1/2, which turns into du equals 1/2 square root of x dx. When you got a function in this problem, you go ahead and move the function also to, because there's no 1/square root of x in this problem, you just move it to the du side, but then you got to substitute in for that x to be in terms of u, and then you literally replace the dx in this case with 2 u du, and the square root of x with u, and clean them up, and that gets you your answer. All right, try this one. It says this. A particle is moving along the x-axis if its velocity at time t is the square root of t in meters per second. Find the average velocity of the particle between 0 and 4. Average velocity. Okay? And they gave you the velocity function. V of t is equal to the square root of t. This, when you hear the word average, in Spatial Account 2 class, you should think of the what we call the average value formula. So another formula, you need to put it in your notes. The average value formula is equal to 1 over b minus a times integral from a to b of f of x dx. And that average, since we're talking about average velocity, we got the velocity function, talking about the average velocity. It's the average value of your function. This is the formula. So here, this average velocity, using my average value formula, we're going between 0 and 4. A is 0, b is 4. This would be 1 over 4 minus 0 times integral from 0 to 4 of the square root of t dt. Cleaning them up, this is equal to 1 over 4 times integral from 0 to 4 of t to the 1/2 dt. And so this will be 1/4. When you integrate t to the 1/2, you add 1. That'll be t to the 3/2 over 3/2, evaluated from 0 to 4. Clean it up. 2, that'll be 1 over 4 times 2/3. T to the 3/2, evaluated from 0 to 4. You can clean this up. 2 goes into 4 2 times, so this is 1/6 t to the 3/2, evaluated from 0 to 4. And fundamental theorem of calculus, you plug in top minus plug in bottom. This will be 1/6 times 4 to the 3/2 power minus 1/6 times 0 to the 3/2 power. Well, that's just 0 there. 4 to the 3/2 power. The denominator is the radical, so we're talking about the square root of 4, which is 2. Cubed makes it 8, times a 6 makes it 8/6, and you reduce 8/6 to 4/3, and that would be meters per second. The answer is C. However, if you are concerned about decimals and fractions on this test, and you're on the section that has a calculator allowed, even though I'm not allowed to have the calculator until the first hour of the exam, I could, once I am allowed to have the calculator, go back on this section and sit there and do this. This would be 1/4 times math number 9, the integral from 0 to 4 of the square root of, no, I'm talking about the original problem. 1/4, integral from 0 to 4 of the square root of x dx. And can I use my calculator just to double check that I didn't screw this problem up? I get, it's thinking about it, 1.333336. I got a little bit of rounding error, but 1.33333, same thing as what? 4/3, so I'm feeling real good about my problem. And I can do the same thing to this guy over here, in case you were concerned about these fractions. This will be in math number 9, the integral from 0 to, it was 0.5 actually, 0.05 to 0.12 of 200x dx. And I can just double check that guy there, and I end up getting 1.19, so I'm feeling real good about that answer too. But I do this after you're allowed to have the calculator. Doing it before is called cheating, and you get thrown out of university for that. So remember that. All right. Here's another one. More formulas. As I go through these things, I'm also trying to remind yourself of all the things you've discussed in calculus 2 this semester. The following table gives the values of a certain function f. 0 to 2, f of x equals 1 through 5. Compute Simpson's rule for f on 0 to 2 using n equals 4 partitions of equal width. First things first. What's Simpson's rule? Simpson's rule, Sn is equal to delta x divided by 3 times f of a plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3, there, plus f of b. It's the 4, 2, 4 pattern, but it's delta x over 3. Just to remind you what Simpson's rule is. The 4, 2, 4. You started on 4, end on 4, and n had to be what? Even. So, in this problem here, we got n equals 4, so that's even, that's great. Your delta x is going to be b minus a divided by n. That's 2 minus 0 divided by 4, which is equal to 1/2, and that makes sense to the chart. 0, 1/2, 1/2 to 1, 1 to 1.5, 1.5 to 2. So it's been moved by increments of 1/2. So, here we go. My Simpson's rule for 4 partitions, delta x, which is 1/2 over 3 times f of your endpoint 0 plus 4 times f of 1/2 plus 2 times f of 1 plus 4 times f of 3/2 plus f of b, which is 2. So this gives you S4 is equal to 1/2 divided by 3 is 1/6 times f of 0 is 1 plus 4 times f of 1/2 is 2 plus 2 times f of 1 is 4 plus 4 times f of 3/2 is 2 plus f of 2 is 5. Now all I got to do is add this stuff up. And so, just to show you, 1/6 times 1 plus 4 times 2 plus 2 times 4 plus 4 times 2 plus 5. I must have screwed something up because I don't see 108. Oh, that's a, hold on, double check it. 1/6, there's my problem now, 1/6. Type it in, 1 times 4 times 2, 2 times 4 plus 4 times 2 plus 5 is, I got 5. So S4 is equal to 5, which is one of my answers there. Just be careful when using your calculator and don't use it so quickly. Does that make sense? Again, what does this remind you of? Not only do you need to know Simpson's rule, you need to know the trapezoidal rule, the midpoint rule formula, as well as left and right Riemann sums. And don't forget to double check your calculator just to make sure you have your program on there. Riemann sum program. However, could I use that Riemann sum program on this problem? Nope, because it didn't give me a function. They gave me a table, so I actually have to use the formula for this. All right, take a look at this problem here. More formulas. Find the centroid or center of mass of lemma bounded by the curve y equals 2 minus 2x squared and the x-axis, and assume the lemma has uniform density. All right. First thing you want to do when you want to find center of mass or whatever, and you got a function, is this. Draw your function out. 2 minus 2x squared. Well, that's x squared minus negative 2 times that's an upside down parabola. Looks like this. Y equals 2 minus 2x squared. And the x-axis, which is right here, and you got your points of intersection on this side here, which is between -1 and +1. You can also put them on the calculator if you're not that familiar with your classic graph here. Y equals 2 times x squared, in case you can't see that there. There we go. All right. Now, Center of mass. Well, just to remind you, this one is actually a little bit easier than you think. You're thinking, oh my God, I got to find the center of mass. I got a lot of formulas for this thing. Well, got a question for you. Before you start the problem, you look at the thing and go, what do you think that center of mass is on this particular equation? Between this function and the x-axis, where's it at? I think it's right about there. Right? That'll be right there in the center. But it's a little bottom heavy, so it's more towards the bottom. But what do you notice? You're actually on the y-axis. So x is going to have to be 0. So I know this point is going to have to be 0, comma something or other. Well, that pretty much eliminates like most of the answers. And I haven't really started this problem yet. So the answer is either A or C. Okay. And all I did was observation because I have a brain. You should use yours on the exam as well. Draw this stuff out and pinpoint it. Now, knowing that fine fact, here, all I need to do now is to figure out the y-coordinate. Remind you, x-coordinate, I don't need it, but I'm trying to write down the formulas for you guys. The x-coordinate is the moment about the y-axis divided by the mass, and the y-coordinate is the moment about the x divided by the mass. These are your formulas, and I'm going to try to write all of them down here for you. The mass is density times the area, which will be density times integral of pretty much top minus bottom dx type thing here from A to B. Just reminding you guys of the formulas. The moment about the x-axis is the tendency to teeter-totter or rotate around the x-axis. That is just like the going around the x-axis. That's the disk-washer method, but instead of pi, you got rho over 2 times integral from A to B of your top function squared minus your bottom function squared dx in this formula. And the moment about the y-axis is equal to rho times integral from A to B of x times top minus bottom dx. These are the formulas you're supposed to have memorized for the center of mass problems. But because of the location and using my brain on this particular problem, all I need to do is find what the y-coordinate is. Does that make sense? Because clearly the center of mass has got to be on the y-axis, which makes x equal 0. So I need two things. I need to know the mass. Mass is equal to density times the area. The area of the curve is basically you just got to integrate the function because we're talking about the x-axis here. It would be integral of 2 minus 2x squared dx from negative 1 to 1. Okay? And honestly, I can integrate this thing by hand, but I've done enough of those kind of problems, so I'm going to start using my calculator to integrate on these setup problems. Math number 9, integral from negative 1 to 1 of your function 2x squared, excuse me, 2 minus 2x squared, try that again, 2 minus 2x squared dx. Does that make sense? And I end up getting, I put in a fraction just to make it a little easier for me, I get 8/3 on this particular problem. Okay? And that'll be the mass. Does that make sense? And I get 8/3 rho. To get the moment about the x-axis, the moment about the x-axis is rho over 2 times integral between a negative 1 and 1 of your top function, which is 2 minus 2x squared minus the bottom one. I'll put it in there for you. 0 squared dx. Top function squared minus bottom function squared, but the bottom function is 0. I didn't even write them up there. So I'm going to integrate this guy, math number 9. The rho over 2. Don't forget you're divided by 2 on this thing here, but I'll put that in just a second. That'll integral from negative 1 to 1 of parentheses 2 minus 2x close parentheses squared. No one cares about minus 0 squared dx. But don't forget, there's my answer, but I got to divide it by 2 for that rho over 2 part. And when I do that, converting it to a fraction, I get 16/3 rho. Okay? So, double check my math on this one. But so the y-coordinate, which is the moment about the x-axis, divided by the mass, would end up becoming let's see here, 16 third row divided by 8 third row. I must have made a mistake somewhere here, because that's going to flip up and give me 2, and that's not going to be one of my answers here. What was this guy here? Row over 2 squared. Double check my problem over here. Negative 1 to 1 of 2 minus 2x. Oh, I have a typo. If the function is 2x squared and I got a square, I left off a square. That was my fault. Oops, let me go back over here and make that a square. There you go. That was my fault on this one. And then I get the fraction 64/15, but then I got to divide that by 2, and I get 32/15. So the moment this would be 32/15 here. 32/15. Just be careful when you're typing this stuff on the calculator that all the parts are there. And what's a clue was the fact is that the answer wasn't there when I was doing it. So this would be 32/15 divided by 8 thirds row. And so what you got here is the rows end up canceling. So this is 32 over 15 times 3/8. And so you can reduce that, or just go ahead and do this. 32/15 times 3 divided by 8 gives me 4/5. So the y-coordinate is going to be 4/5. And I didn't even have to calculate the x-coordinate because I used my brain and symmetry on this one. So the answer is going to be 0, 4/5 as your center of mass, which means the answer is A. Does that make sense, though? And when you're doing the calculator, just take your time and plugging it in, especially on these problems. You're on part number 2 and part number 3. Now, part number 3 is free response. So you're going to show your work, but I'm still going to double check my integrals on my calculator if I got a chance, because I'm allowed to have the calculator. Here's another one you need to know. Arc length. Which of the following gives the length of the curve of y equals x squared from -1 to 2? What is the formula for arc length? Arc length, there was 2 formulas you need to memorize. It was the integral from a to b of the square root of, what was it? Right, 1 plus the derivative squared dx. And its dx would be the derivative of the x function squared. If you had a y function here, it would be f prime y dy. Okay? So my function they gave me is x squared. So its derivative is 2x. So I'm going to plug 2x into this thing right here. So this would be the integral. They gave me the bounds from -1 to 2 of the square root of 1 plus 2x is my derivative squared dx. And that's not how they wrote it, so I'm going to have to clean it up one more time. Integral from -1 to 2 of the square root of 1 plus 2x quantity squared. Well, 2 squared is 4, x squared dx, which means the answer is E. But again, this one was easy as pie, but I just got to remember the formula. Oh, we got a series problem. Yay. All right, here we go. Which of the following series tests can be used successively to determine whether the sum n goes from 1 to infinity of n over 2n cubed plus 7 converges or diverges? Here's how you should handle a problem like this. Before you decide on which test and pick out your answer, first try to figure out, is this thing going to converge or diverge? This is what I call the mental comparison test. All right? It's either the direct comparison test or the limit comparison test, but you got to know who to compare to. On this particular problem, who would you compare to? Remember, your degree terms are your commanders. So I'm going to put the little squiggly equal to, this is who I would compare to. The sum as n goes from 1 to infinity of n over 2n cubed. Clean that up. That's the sum as n goes from 1 to infinity of, pretty much n goes into n cubed, n squared times 2n squared. The 1/2 goes out front. No one cares about your constant, but it is 1 over n squared. What kind of series is that guy right there? The sum as n goes from 1 to infinity of 1 over n squared. P series. P equals what? 2. I'll write that down. P series. P equals 2, which means it converges. Which means this series right here converges by the mental comparison test. I actually didn't do a test, but I know who to compare to, and since the guy I'm going to compare to converges, I know this guy converges. So, first...
I found this on the web for which way
Thank you. My phone again. Okay. I should turn my phone off. Okay, so now, here we go. With this, I know it's going to I know the thing is going to converge, but they didn't ask me that, but they did ask me, what would I do? Could I do a direct comparison test? First off, is this an actual p-series? No. A p-series has to be the sum of 1 over n to a p. You don't care about a constant, but anything added or multiplied, n on top, n on bottom, no, that's not a p-series. We're comparing it to a p-series. Would I ever use a ratio test on this thing? Lord, no. Okay, no powers of n or factorials. It doesn't, divergence test, since the denominator is bigger, it does go to 0, so that's out. Direct compare to the terms of 1 over n. Well, I would do a direct comparison test, but not 1 over n. That's a harmonic series with divergence. We're going to go to 1 over n squared, which pretty much tells me the answer is this guy right here. And I can do the direct comparison test since this guy converges, and when you add 7 to the denominator, it makes the denominator bigger, but the overall fraction is smaller. This converges, and this is smaller than converges by our theorem. Anything smaller than converging will also have to converge. So if you're comparing it to convergent, you got to be smaller for the direct comparison test. If you're comparing it to divergence, it's got to be bigger. Remember your inequality stuff. So this is definitely my answer. It's definitely not a p-series itself, but you would compare it to a p-series. So here's another one. Find the interval of convergence of this particular problem. When I need to find the interval of convergence, what test will I use every time? Ratio test. So I'm going to treat this as if it was a free response question, because it darn well could be. They happen to put this one on the multiple choice part. So we're going to use a ratio test. And so I'm going to take the limit as n approaches infinity of the absolute value of an plus 1 over an. This will be equal to the limit as n approaches infinity of the absolute value of negative 1 to the n plus 1, x to the n plus 1, divided by n plus 1 times 2 to the n plus 1. All I did was take all the n's and put in an n plus 1 in it, divided by an, which is negative 1 to the n, x to the n over n times 2 to the n. Now, here's some quick math for you. What does an absolute value do to a negative 1 to any power? I don't care what it is. Absolute value is going to kill it off. So I'm not just killing these guys off because they're going to cancel, which parts of them do. The absolute value is just going to completely kill them off. So this is equal to the limit as n approaches infinity of what's left, which is x to the n plus 1 on top, n plus 1 on bottom, 2 to the n plus 1 on bottom. I'm going to invert and multiply, so the 2 to the n will flip up to the top. The x to the n is going to be on the bottom, and the n is going to be on top. Now, lots of stuff we're going to cancel here. What cancels? Well, you've got x to the n plus 1 over x to the n. Which one has more? Top or bottom? Top. How many more does the top have? X to the n plus 1 is x times x to the n, and the x to the n's will cancel. Look at your 2's. 2 to the n divided by 2 to the n plus 1. This 2 to the n divided by 2 to the n plus 1. 2 to the n plus 1 is 2 times 2 to the n. The 2 to the n's cancel. So this is equal to the limit as n approaches infinity of the absolute value of x over 2, and then the n's are still left over, n over n plus 1. Now, take your limit as n approaches infinity. Because you've got n divided by n plus 1, you're just focusing on the n's here. You can use L'Hopital's rule or the fact degree of the top is degree of the bottom. What is the limit as n approaches infinity of n over n plus 1 going to go to? 1. So you're left with the absolute value of x over 2. This is the ratio test. Where the ratio test converges when the L, which in this case the L is absolute value of x divided by 2, is less than 1. Which means when you solve this guy, negative 1 is less than x over 2, which is less than 1. Then you multiply by 2 on all sides, and I get negative 2 is less than x, which is less than 2. This is almost my interval of convergence. I got to do one thing. What do I have to do? Well, actually two things. Check the endpoints. So the last thing I'm going to do here is check my endpoints, because the ratio test doesn't say squat about the endpoints. So the endpoints, x equals negative 2. Plug negative 2 into your function. And be careful. This will be the sum as n goes from 1 to infinity of negative 1 to the n Replace x with negative 2 to the n, over n times 2 to the n. Clean them up. This is the sum as n goes from 1 to infinity of negative 1 to the n times negative 1 to the n times 2 to the n over n to the n. Now what did I do here? What I did here was this negative 2 to the n. It's negative 1 times 2. So I distribute power. That negative, I pulled him off. That's negative 1 to the n times 2 to the n. So you got negative 1 to the n times negative 1 to the n. They both have the n power, so you can factor it out. What's negative 1 times negative 1? 1. So this ends up becoming 1 to the n, which is just 1. The 2 to the n's end up canceling, so this turns into the sum as n goes from 1 to infinity of 1 over n. What kind of series is that, guy? You're supposed to recognize him. Harmonic series. And what does the harmonic series do? Diverges. Harmonic series diverges, which means I do not want this x equals negative 2 in my interval of convergence. Does that make sense? And then the other endpoint is x equals positive 2. This will be the sum as n goes from 1 to infinity of negative 1 to the n, 2 to the n, just plugging in for x, 2 to the n divided by n times 2 to the n. The 2 to the n's cancel. This is the sum as n goes from 1 to infinity of negative 1 to the n over n. What kind of series is this guy? And you shouldn't be surprised by this fine fact. What is it? Alternating series. It's actually the exact same series, but one side's going to be alternating, the other side's not going to be. This is an alternating series, so we're going to use the alternating series test on it. And what does the alternating series test say? Well, you look at your Bn, the part without the alternation, which is 1 over n, and you got to check two things. You got to make sure the terms go down. N equals 1, n equals 2, n equals 3. That'll be 1 over 1, 1 over 2, 1 over 3. Yep, the terms go down. And number 2, you got to take the limit as n approaches infinity of the Bn. This is the limit as n approaches infinity of 1 over n. What is 1 over infinity? Is 0. And if the terms go down and then the limit goes to 0, what is this going to do? By the alternating series test, this thing converges, which means I want x equals 2 in my interval answers. So to show that, I put an equal to on the 2. And if I write this in interval notation here, in interval notation, this would be parentheses negative 2 to bracket, which is answers B. But this is how you would write out. Now, I can obviously cut out some of the math in my head if I'm not having to be so elaborate in showing my work. But if this is a problem on the free response, these are all the parts we expect to see. This is pure memorization. Free points if you know it. Have to take a class again if you don't know it. Here it is. Which of the following Maclaurin power series is the expansion for the sine of x? Pure memorization. There were 5 of them you're supposed to have memorized. Which one is the sine of x? Remember, cosine is an even function, so you're looking for the even powers. Sine is the odd. Arctangent is just like the sine, it's odds without the factorial. So there's 3 of them memorized. The classic e to the x is just the famous 1 plus x over 1 factorial plus x squared over 2 factorial. I mean, they're easy to memorize if you can catch patterns. This is sine, so it is odd, and it'll be odd powers would be x minus x cubed, and it's got to have the factorial in it. So it becomes real obvious, no work to be done. The answer is D, pure memorization. 5 of the Maclaurin series in chapter 8.7 you're supposed to memorize. Now, let's take a look at this guy. This one tends to throw people off here. Here's a series. 1 minus 1/4 plus 1/9 minus 1/16 plus ... Is this thing going to converge or diverge? Well, first off, you've got to figure out what kind of series it is. So, this is n equals 1. This is n equals 2. This is n equals 3. This is n equals 4. What seems to be the pattern here? First, it's alternating. So this actually turns into the sum as n goes from 1 to infinity of, it's alternating, it's negative 1. See, I want it to the n plus 1 actually, because we're starting out positive. Divided by, look at your powers. When n was 1, it's over 1. When n is 2, I get 4. When n is 3, I get 9. What's the pattern? It's n squared. You got to recognize the pattern. 4, 9, 16. These are your numbers squared. 4 is 2 squared, 9 is 3 squared, 16 is 4 squared. Well, 1 is anybody, 1 squared. Yeah, there you go. So this is my series. It's an alternating series. And being an alternating series, I can use the alternating series test on this guy. But the fact of the matter is this thing is absolutely convergent because when you take the absolute value of it, it's the P series, P equals 2. But it is an alternating series, and your Vn is 1 over n squared. So number one, when you plug in your numbers, I'm just doing the test for you because you guys need to practice. 1 over 4, 1 over 9. Yep, the terms go down. And number two, when I take the limit as n approaches infinity of 1 over n squared, I get 1 over infinity squared, which is 0. It converges. So the answer is it converges. So it's clearly not going to be e. But the problem is, okay, I got it converging, but what's it going to converge to? Is it a number between a half? Is it less than a half? Between a half and 3/4? Between 3/4 and 1, or bigger than 1? Well, since it's an alternating series, we can sit there and just add up a bunch of the terms, and let's see what the number's going to, because we're going to approximate this thing. So let's find, for example, what is S4? S4 will be 1 minus 1/4 plus 1/9 minus 1/16. Let's see what we got. Let's just add up the numbers. We're allowed to use the calculator at this point. So this will be 1 minus 1/4 plus 1/9 minus 1/16. This is S4, and I get the number 0.7986. That's a clue. If I add one more term, what would the next term be? Minus the 16th, it'll be plus 1 divided by, that's 4 squared, so the next one's going to be 5 squared, which is 25. We're going to 0.836, and if I add on the next term, which will be minus 1 divided by 6 squared, which is 36, I'm back to 0.81. So it looks like we're going around, 0.79, 0.838, 0.81. These 8108, these are the numbers it's going towards. And it's getting closer to 0.8 something or other. You with me? And what is 0.8? 0.8 is at less than a half, between a half and 3/4, between 3/4 and 1 or bigger than 1. Well, mind you, 3/4 is 0.75. We're getting around 0.8 something or other. So what's the answer? It's got to be inside here. The answer is C. And all I had to do was just add up the numbers. Okay, here we go. This is how they like to ask you an easy Taylor series problem. The coefficient of the x minus 1 cubed of the Taylor series expansion of f of x equals x to the 6 minus 2x is what? Okay, so first off, what's Taylor series? That's right, it's named after my great-great-great-granddaddy. What is Taylor series? It is f of x is equal to f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime of a over 3 factorial times x minus a cubed plus dot dot dot. See, right here, they're talking about Taylor series, but if you're going to do a Taylor series, you've got to have a centering point. Since they're talking about these terms right here, x minus 1 cubed, what does a have to be? The terms on the Taylor series, x minus a. We're talking about this term right here. This is what we're after. X minus a cubed. I want the coefficient of x minus 1 cubed. So what is a equal to? You got to play detective work, but what's a? Yeah, it's 1. That's what we're going to be plugging in. And this is the coefficient that I need right here. It is the third derivative divided by 3 factorial. So what I want, okay, so my function is x to the 6 minus 2x. What's my first derivative? That's 6x to the 5th minus 2. What's my second derivative? That is going to be what? 30x to the 4th. Agreed? What is my third derivative, which is my guy? What's my third derivative? 4 times 30 is 120x cubed. There's my third derivative. But what's my centering point? 1. So the f triple prime evaluated at 1 is going to be 120 times 1 cubed. which makes it 120. Just to show you, the coefficient of the Taylor series is the triple prime at 1 over 3 factorial times x minus 1 cubed. This is the coefficient that I'm trying to find. Does that make sense? It's this guy right here. They wanted of x minus 1 cubed. That's x minus a cubed. This is the coefficient. They say find the coefficient. Well, I figured out what the triple prime is, evaluated 1, that's 120. So this is going to be 120 over 3 factorial times x minus 1 cubed. All I'm focusing on is that one term, because that's all they asked me for. What's 120 divided by 3 factorial? Well, that's 120. 3 factorial is 3 times 2 times 1, which is 6. 120 divided by 6 is 20. This will be 20 x minus 1 cubed. And so the answer is C. The coefficient would be 20. For the x minus 1 cubed in the Taylor series, it's the third derivative evaluated at 1 divided by 3 factorial. I had to find the third derivative evaluated at 1 and then divide that by 3 factorial. That's where my 20 comes from. Yeah? It
was x minus 1 squared. Would that just be the second derivative?
That's correct. This is the Taylor polynomial. So the coefficient of x minus 1 squared would be the second derivative evaluated a divided by 2 factorial. If it was x minus a to the fourth, it would have been the fourth derivative evaluated at a divided by 4 factorial. Does that make sense? So it's the pattern of the Taylor series. Here's another one of these classic problems, and there's no way to go to handle this one except for go through each question, each answer here. Exactly, one of the following series converges. Which one is it? Which series is it? Find the one that converges. Well, let's go through them. What's this dude's name? The sum of n goes from 1 to infinity of 1 over n. And what does the harmonic series do? Diverges, so that ain't it. What is this guy's name? Let me rewrite him for you. It's the sum of n goes from 1 to infinity of 1 over n to the half power. It's a p series. P equals a half, but that's less than 1, so it diverges, so it ain't him. What about this guy here? Well, it's an alternating series, but when I do the alternating series test on this guy and take the limit as n approaches infinity, I just happen to notice the Bn part, which is n over 4n minus 1. The degree of the top equals the degree of the bottom. That's going to go to 1/4, which is not 0, so that automatically makes it diverge from the alternating series test. It's either going to be this dude here or this dude here. Well, the answer is going to be this dude here, because again, I'm going to use the alternating series test, but I'm going to eliminate, before I do this one, I'm going to do this one. What kind of series is this guy right here? Geometric series. If you've got a series that has nothing but maybe a constant, but numbers raised to powers of n, and that's it. Numbers to powers of n, that's a geometric series. They're starting at 0, so pay attention to that. So this one is a geometric series. And the formula when you start at 0 is r to the n. And if the absolute value of r is less than 1, it converges to a over 1 minus r. And if the absolute value of r is greater than or equal to 1, it diverges. So on this one, they got 5 to the n minus 1. I want an n power here. I'm 1 short. So let me show you the pattern here. If I'm 1 short, I'm going to give him exactly what he needs. I'm going to give him another 5. But whatever I do to the denominator, mathematically, I do to the numerator, makes a ratio of 1. So this ends up becoming the sum as n goes from 0 to infinity of negative 6 to the n times 5 over 5 to the n minus 1 times 5 makes it 5 to the n. When you clean that up, this is n goes from 0 to infinity of 5 times negative 6/5 to the n. So your a in this problem is 5. Your r is negative 6/5, but absolute value of r, absolute value of negative 6/5 is 6/5, which is greater than 1, which means this series, geometric series, is going to diverge. Good little math to show you guys on that one. Okay? So this one, I'm going to use the alternating series test on it. The Bn part is the part without the alternation, 1 over 4n minus 1. And I'm going to do my 2 little checks. Number 1, I'm going to show you the terms go down. This thing starts at 1. N equals 1, n equals 2, n equals 3. So when I plug in 1, 1 over 4 minus 1 is 4 minus 1 is 3. Plugging in 2, 4 times 2 is 8 minus 1 is 7. Plugging in 3, 4 times 2, so 4 times 3 is 12, minus 1 is 11, 1 over 11. Yep, my terms are going down. And number 2, when I take the limit as n approaches infinity of 1 over 4n minus 1, that gives me 1 over infinity, which equals 0. By the alternating series test, this thing converges. So the answer is D. So I'm actually trying to remind you of the test, just as if that was a free response kind of a question. Now, on to part number 3. Part number 3. And I told all my students this the other day, and I'm going to reiterate myself. Look, this is the final exam. Before I even start part number 3, there's going to be some problems on here that you may have never seen before. That's the way we like to put the final exam. Separates the A students from the B students from the C students and so forth and so on. However, you have been through Calculus 2. You know something. When you come across a problem that you've never seen before, number 1, write down what you got. Look for the question, figure out what they're asking you to do, and then make a plan. You know calculus, you know integration, so when in doubt, integrate the darn thing. But basically, try to make a plan of what I've got and what can I use based upon my knowledge to get a solution to my problem. Never leave anything blank. We do grade this thing off with partial credit, so never leave anything blank. If you know something, write it down and try to make a connection between the two. Okay? Also, very important, be neat and be organized. If you're sloppy, we can't read this stuff. And if I can't read this stuff, it may be right or not, I don't know, but if I can't read it, I'm going to mark it wrong. This is what we do. You understand, this is off semester for Calculus 2, so we got about 800, 900 students taking Calculus 2 this semester, okay? I've got 900 exams to grade. The grading committee, every one of us professors gets one problem, and we grade this one problem 900 times, okay? And we try to go through this rather quickly. So we look at your work, and if I see work that we can follow along and a correct answer, great, full credit, boom, next problem. If I see work, the answer's wrong, then I go back and look at the work. If I can see where you made the mistake at, and if it's a careless error or something or other, I can give you some points for setting it up right, but you lose a couple of points for a careless error. If I get a problem that I can't read at all, and it's just the wrong answer, and I can't figure out what you're doing, well, that's easy. I'm not going to give you squat. 0, next problem. Because I got to do this 900 times. I'm going to cruise through this thing. Every professor does it the same way. So if you're neat and you're unorganized, your grade will go up because we'll be able to read what you're trying to do. Okay? There's some hints for you. Let's take a look at this thing. All right. Free response with a calculator here. Let me blow this up so you guys can see it in the back. All right. It says though, number 1, even though calculators are allowed, you must show all your work. Okay? And that's key to this thing. And if it's some kind of a decimal or something, rather, they want 4 decimal places. We're good about that. You know? So here's the first problem. Find the volume of the solid created by rotating the region which is bounded by the curves y equals 6x minus x squared and y equals x about the given lines below. Okay? Be sure to clearly set up the definite integral and label all parts. Feel free to use your calculator to obtain the exact value of the integral. They even tell you, use the integral. We're going to grade the setup of the integral. All right. So first off, I got this thing here. I'm going to draw my picture. Okay? Y equals 6x minus x squared and y equals x. So go to y equals, in case you're not familiar with it, 6x minus x squared. And y equals x, and I'm going to do a zoom 6 on that thing, and I get an upside down parabola, and I get a line cutting right through it. Boom. So I'm going to draw this picture over here. Draw pictures. That's worth at least a point. So this is the equation y equals 6x minus x squared, and the line y equals x looks like this. Here's the line y equals x. So we're talking about bounded by these two curves. We're talking about this region. I do need my points of intersection. One of them is pretty obvious. It's 0 right here. The other point of intersection is this, and I'm going to second calculate, because they said I could use my calculator on this thing, find the intersection. I go over here, there's my first curve. I'm gonna go to my point of intersection, I want to hit enter, second curve enter, and I guess it's right about there, and the x-coordinate is 5. This is 5, okay? Now, here are my points of intersection. My functions are in terms of x. Listen to my words. My functions are in terms of x, and they want us to rotate about the x-axis. Now they're telling me, they shouldn't have given me a hint on this one because it should be pretty obvious. If my function is in terms of x, and I want to rotate around the x-axis or something parallel to the x-axis, what method am I going to use every time? Disk washer. The disk washer formula is volume is equal to pi times integral from a to b of the big functional radius squared minus little functional radius squared dx. These were your classic formulas that I came up with you guys for. Your big functional radius is from the distance from the axis of rotation to the outside edge of your region. We're going around the x-axis here. This is my axis of rotation. So from the x-axis, which is y equals 0, to the outside edge, my big radius is going to be 6x minus x squared, minus officially 0. So it's pretty much the top function, which is just 6x minus x squared. The little radius is from the axis of rotation to the inside edge, which is just x minus 0, which is x. So my volume is equal to pi times integral over my points of intersection, 0 to 5, of my top function, which is that big radius, 6x minus x squared, minus the little radius, which is x squared dx. This is what they want. Okay? Be clear to identify and label all my parts and stuff like that. I've done all that. And they feel free to use your calculator to obtain the answer. So typically with this type of stuff, we like to leave the answer in terms of pi. So here we go. Math number 9. This would be the integral from 0 to 5, leaving the pi off, of parentheses 6x minus x squared, close parentheses, squared, and I'm not trying to rush through this one, so I'm going to make sure I don't screw it up, parentheses x, close parentheses, squared, dx. Double check yourself, take your time on the calculator, and I left the pi off, so I'm going to hit enter, and that gives me 208.33333 pi, putting the pi back on there, what? Units cubed. Why is it units cubed? Volume. Because what you've really done is you've rotated this thing about the x-axis. So you've got that three-dimensional shape. Does that make sense? Okay? We would also, if you wanted to put it in decimals, we accepted the decimal answer. For those people that just love fractions, 625 over 3 pi units cubed was also acceptable. So there you go. And if you wanted to put that in decimals and put the pi in there, you got 654.4984. Yeah, we took that one too. But we were really grading this and looking at your work. And work requires the picture. Okay? Part B. Take the same region. Now we're going to rotate around the y-axis. So, same region. This is y equals 6x minus x squared. This is y equals x. We're talking about this region here between 0 and 5, your x-axis, your y-axis. But this time we're going to rotate around the y-axis. Now, they shouldn't have had to give you the hint because I can't guarantee they ever do that. But the fact of the matter is you should notice this. My functions are in terms of x, but now we want to rotate around the y-axis. What method is the natural method to integrate when the function is in terms of x of your region and you want to rotate around the y-axis? What method? Shell method. So this one is the shell formula. This one was the disk washer is what I called it. Okay, so this was disk washer. This is your shell method formula. And the formula is volume is equal to what? 2 pi times integral from A to B, or what I call the point radius, times f of x top minus g of x bottom dx. This was our formula. Okay? Now, so volume is equal to 2 pi times integral from 0 to 5 of, what is the point radius? You pick an arbitrary point inside your region and you find the distance back to the axis of rotation. But the axis of rotation here is the y-axis, which is x equals 0. So your point radius ends up being right minus left, which is x minus 0, which is just x. So pretty much, when you want to rotate, you got function in terms of x, and you want to rotate around the y-axis, the point radius is going to be x minus 0 or x. It's when you rotate around another axis parallel to the y-axis, you get that x minus number or number minus x, depending on which side the region is on. Okay? Times top function, which is 6x minus x squared, minus the bottom function, which is just x dx. And this is perfectly fine. This is what we were looking for to grade. You could combine like terms and clean it up if you wanted to. That's strictly up to you. We accepted that answer of 2 pi times integral from 0 to 5 of x times 6x minus x officially makes it 5x minus x squared dx. If you wrote that, that's fine too. But as we said, we're going to use the calculator to integrate this thing. So I'm going to put the 2 on there, but I'll leave the answer in terms of pi. Math number 9, integral from 0 to 5 of x, and I'm going to type it in this way, times parentheses 6x minus x squared, and I'm going to put an extra set of parentheses in this thing because I want to make it look exactly like this because I don't want to screw it up because I made some bonehead careless error on my calculator. Minus x dx. Double check my parentheses here. Oh, gotta have a parenthesis for the whole thing. I double check it. That looks good. I hit enter, and what do I get? I get 104.166667 pi back on the answer, units cubed. Also accepted for those people that love fractions, 625.6 pi units cubed. 327 was also accepted on that problem too. Does that make sense? So however you want to give it, but this is what we're grading. But the big picture is the picture, the formula, and you plugging the stuff into the formula. That's what we wanted to see on this problem in terms of the free response. Question. Next one, series problem. Determine whether the following series converging or diverging. Be sure to state the series, the test you used, and state all the steps needed to perform the test. State whether the series is converges or diverges. All right, so here we go. First dude here. The sum as n goes from 1 to infinity of 4 over 2n plus 3. What's your feeling? This thing going to converge or diverge? Why? Well, it's not harmonic, but it looks awfully much like a harmonic, right? So you're right. I would compare to a harmonic series. The problem is adding 3 to the denominator makes the denominator bigger, fraction smaller, and the harmonic series diverges. So I'm pretty much limited to doing this. I would use the limit comparison test. So I'm going to do the limit comparison test. I'm going to compare to the sum as n goes from 1 to infinity of 1 over n. What's this dude's name? Harmonic series. And what does the harmonic series do? Diverges. Okay, stating all what I'm comparing it to. Now, my limit comparison test, I'm going to take the limit as n approaches infinity of the sequence part of the unknown series, 4 over 2n plus 3, divided by the sequence part of the known series, 1 over n. You're comparing the sequence part. And remember what the limit comparison test says. When I take this limit and I get a number, it can't be 0 and it can't be infinity, but I get a number, and if I get a number, then these two series are going to do the exact same thing. And then we're comparing it to a divergent harmonic series, so this thing should diverge. So I'm going to clean this up. This becomes the limit as n approaches infinity of, invert and multiply. That gives you 4n over 2n plus 3, which equals what? Now, you can use L'Hopital's rule if you want to, or just tell me what the answer is. 4 divided by 2, which is equal to 2. This is your C value, which is not 0 and not infinity. Therefore, by the limit comparison test, I showed you that the limit of the sequence part of the unknown series to the known series gives me a constant. Then therefore, by the limit comparison test, the sum as n goes from 1 to infinity of 4 over 2n plus 3 is divergent. And I showed you the proof. Does that make sense? Another test I could have used is I could have used the integral test, because I can integrate this thing. The integral from 1 to infinity of 4 over 2x plus 3 dx. Use some U-substitution. It's an improper integral, and I could have done it that way. There's more than one way to do it, but there's only one answer. It's divergent. So remember that on these problems. So after the test, hey, you remember that problem number 2? What did you get? Oh, I used the integral test. Oh, damn, I failed the class. No, not necessarily. There's more than one test that you can use on this one. I would have done this because that looks, it's not harmonic, but it looks awfully much like a harmonic, so I can compare it to the harmonic series. So that was faster than actually trying to do the integral test. But the integral test would have been perfectly acceptable. I would not have used the ratio test on this thing. Okay, no powers of n, no factorials, just to let you know. Yes, ma'am? No, I could not have used the direct comparison test. Let me tell you why. Since we are comparing it to a divergent series, the guy that you're comparing it, the original term has to be bigger than the guy you're comparing it to. When you add 3 to the denominator, it makes the denominator bigger, but makes the overall fraction smaller, and you're smaller than divergent, so your direct comparison test doesn't say anything about that. You've got to get that inequality just right. So this really sets up for a limit comparison test. And honestly, 9 times out of 10, if I'm going to do a comparison test, it'll be a limit comparison test, because rarely do I get these inequalities just right, unless I put them on the notes or something. All right, what about this dude here? Oh, somebody already said it. They looked at this thing, and no more than 2 seconds after I scrolled it up here, they said, what test am I going to use? Ratio test. Why? It's got both powers of n and factorials. There's only one test you can use on this dude, ratio test. So I would state that. Ratio test. I'm going to take the limit as n approaches infinity of the absolute value of an plus 1 over an. This will be equal to the limit as n approaches infinity of the absolute value of 5 to the n plus 1 over n plus 1 factorial divided by 5 to the n over n factorial. I'm going to invert and multiply. This is equal to the limit as n approaches infinity of 5 to the n plus 1 divided by n plus 1 factorial. I kind of spread out my numerator and invert and multiply the denominator, so the n factorial shows up on top and the 5 to the n shows up on bottom. Now I'm going to clean this guy up. This is equal to the limit as n approaches infinity of, let's take a look. On this problem, I got 5 to the n plus 1 over 5 to the n. Well, 5 to the n plus 1 is 5 times 5 to the n. I pulled off one of my 5's, and the 5 to the n's cancel, leaving me with 5 on top. In terms of my factorials, n factorial by definition is n times n minus 1 all the way down to 1. n plus 1 factorial is n plus 1 times n minus 1 all the way down to 1. What cancels here? Well, the n's cancel, the n minus 1's cancel, the dots cancel, and the 1's cancel. That does leave you with an n plus 1 in the denominator. So this, cleaning it up, gives me this. Now take your limit as n approaches infinity of 5 over n plus 1. Well, 5 is a constant. Divided by infinity plus 1 is infinity. And 5 divided by infinity is 0. Your L value is 0. So as L equals 0, which is less than 1. Remember, you're stating the ratio test you have memorized. The ratio test, L, when L is less than 1, it converges. Converges absolutely if it's alternating, but it's not alternating. If it's L greater than 1, it diverges. And if L equals 1, shame on you, you waste all your time, try another test. So this one, your L is less than 1. Therefore, by the ratio test, the sum as n goes from 0 to infinity of 5 to the n over n factorial is convergent. And there's my answer. And there is my statement of proof. Does that make sense? This is what we're after. And pretty much this one, you only had really one test to use on this guy. You're not going to integrate this guy or anything else. Yes, question?
How do you know when not to check if it's absolutely convergent?
It'll be in the question. They will ask you the question, is this series absolute convergent, conditional convergent, or divergence? Okay? And they only ask you that question if they give you an alternating series. Only an alternating series could be absolutely convergent, conditional convergent, or divergence. So they have to give you an alternating series and then ask the big question. So if it's absolutely convergent, you take the absolute value around it and drop the -1 to the end and see if that series converges. If it does, we call the alternating series actually absolute convergent. If it fails being convergent at the absolute level, then you put back the -1 to the end and check the alternating series test. If it converges, we call that conditional convergent. If it fails that, there's only one other option. It diverges. So you're ranking your alternating series is what you're doing. All right. Consider the definite integral from 0 to 1 of x squared minus 1 dx. Use the error-bound formula for the midpoint rule to determine the smallest value of n such that mn is within 0.005 of the definite integral from 0 to 1 of x squared minus 1 dx. Recall that, this is all nice of them, that the error-bound formula for this guy is absolute value of error for the midpoint is k times b minus a cubed over 24n squared, where k is the maximum value of the second derivative, absolute value of second derivative is less than k for all x's between a and b, okay? So, basically, we're going to use the error-bound formula for the midpoint on this one. So my function, here it is, f of x is equal to x squared minus 1, okay? My bounds are between 0 and 1. A is equal to 0 and b equals 1. It's from the integral here. So I'm just writing down my formulas here. Okay? So I'm going to use this formula here. The first and the hard part about using the error-bound formulas is you got to find k. For the trapezoid and midpoint rule, k is the maximum value of the second derivative. For the Simpson's rule, k is the maximum value of the fourth derivative. So luckily, all I got to do is take two derivatives of this guy, which is real simple. F prime of x, derivative of x squared is 2x. And then your second derivative is, derivative of 2x is 2. Now, you got to look on the interval between 0 and 1. So if I graph that thing, and I look between 0 and 1, and the second derivative is 2, here's 2 right here. Your k value is the maximum value, but you get a constant. So guess what k is? Don't hurt yourselves. 2, okay? Now, if it was a parabola or something like that, you have to figure out maximum value is the furthest distance, absolute distance, away from the x-axis, okay? Remember, so if it was down here, that point at the bottom, this would have been your k value. You have to kind of evaluate what it is, and remember, k is always positive. It's a positive value. But this one's pretty simple because it's constant by the time you've got the second derivative. So k equals 2. So your error-bound formula for the midpoint is less than or equal to k times b minus a cubed over 24n squared. K is 2 times b minus a, which is 1 minus 0 cubed, over 24n squared. And that's got to be less than or equal to the error, which is your 0.005. Your job now is to solve for n. So they gave you an easy problem to find k on this one. But now I'm going to clean this guy up. 1 minus 0 is 1, cubed is 1 times 2. So this is 2 over 24, n squared on the bottom, is less than or equal to 0.005. 2 over 24, you can clean that up. 2 goes to 24, what, 12 times? 1 over 12 n squared is less than or equal to 0.005. All I'm doing is cleaning up my equation. How would you solve this thing? Personally, I'm going to get rid of the denominator. I'm going to multiply both sides by 12n squared. By multiplying both sides by 12n squared, That's going to give me 1 is less than or equal to 0.005 times 12n squared. Well, I can go ahead and clean that up. 0.005 times 12 is 0.06. So 1 is less than or equal to 0.06 n squared. Now I'm going to solve for the n squared part. So I'm going to divide both sides by 0.06. And this is going to give me, writing it over here, 1 divided by 0.06 is 16.666667. So I get 16.666667 is less than or equal to n squared. And one last move to get that in. What kills off that square? Square root of both sides. So this means your n is going to be greater than or equal to the square root of this answer, which is 4.082, 4.082 whatever. However, I want to remind you, n is the number of partitions. You can only have a whole number of partitions. You can't have a 0.08. Okay, I don't care what the decimal is. You always round it up. And if it's Simpson's rule, you round it up to the even integer. So rounding up, I don't care what the decimal is, gives you the answer n equals 5. Does that make sense? Now, part B. Use the n that you found in part A to calculate the midpoint for the integral from 0 to 1 of x squared minus 1 dx. All right? And again, this is the work we expect to see. So we're going to use the midpoint formula. The midpoint is the sum of f of xi bar times delta x. Delta x is equal to b minus a divided by n. What is my n in this problem? Hope you didn't screw it up. N equals 5. Your a was equal to 0 and your b equals 1. This means your delta x is going to be 1 minus 0 divided by 5, or 1/5. That is your delta x. Now, here we go. I like to draw out my little number line. My a is equal to 0. My delta x is 1/5. So I'm going to move over 1/5. There's my first partition point. I'm going to move over another 1/5, makes it 2/5. I'm going to move over another 1/5, makes it 3/5. Move over another 1/5, makes it 4/5. Move over another 1/5, makes it 5/5, which is 1, and that's my b, where I ended at. These are my partition points. Okay, my ending of my partition point. But we're trying to do the midpoint rule. This is 1, 2, 3, 4, 5 partitions, as we stated. Now I got to find the midpoint. What is the midpoint between 0 and 1/5? 1/10. Add them together and divide by 2. 1/10. So these have become the midpoints. 1/10. What is between 1/5 and 2/5? 3/10. Between 3/5 and 2/5 and 3/5. 5/10, also known as a half, but I'm trying to show you guys a pattern here. What about between 3/5 and 4/5? 3/5 and 4/5. What do you get? 7/10. And between 4/5 and 5/5. Catch a pattern. 9/10. I wrote, 1/2 is 5/10. Who cares? Okay, these are just my midpoint. Add them together and divide by 2 is all I did. So these are my partition points. So the midpoint rule for 5, which is equal to delta x times f of your first partition point plus f of your second partition point plus plus f of your last partition point. Just trying to remind you guys of the formula. Always write down a formula if you know it. It's worth points in case you mess up somewhere. What was delta x equal to? 1/5 times f of your first partition point is 1/10 plus f of your second partition point is 3/10 plus f of your third partition point, which is 5/10 plus f of your fourth partition point, which is 7/10 plus f of your last partition point, which is 9/10. There we go. What is my function in all this stuff? F of x is x squared minus 1. It's the function we're trying to integrate. So this is equal to 1/5 times 1/10 squared minus 1 plus 3/10 squared minus 1 plus 5/10 squared minus 1 plus 7/10 squared minus 1 plus 9/10 squared minus 1 closed bracket. Now at this point, this is very important for getting full credit on a Riemann sum kind of a problem. At this point, I'm going to start using my calculator. I wrote down the formula, I wrote down the numbers I'm trying to plug into the function, and then I actually write down, this is the important part, we want to see the numbers plugged into the function that you would add up. Now, I'm going to put this on my calculator, and I end up getting negative 0.67. Okay, if you don't believe me, we got some time here. So this will be 1/5 times parentheses, 1/10, I can do that kind of math. That'll be 0.1 squared minus 1 plus, I'm just going to do it easier because I really don't need my parentheses, 0.3 squared minus 1 plus 0.5 squared minus 1 plus 0.7 squared minus 1 plus 0.9 squared minus 1, and then close parentheses, all of that's got to be multiplied by 1/5, which gives me, yeah, that's where I got my negative 0.67. But now, for you see, on my calculator, because we did that wonderful calculator project, I also have a wonderful program on my calculator. Make sure I didn't screw up this problem. I got y equals, I'm going to type in my function, clear out the old stuff there. And my function was x squared minus 1. I'm going to second quick, go to my home screen, hit my programs. I got lots of programs. My program is called Riemann. My Riemann sum program, A was equal to 0, B was equal to 1, and I want 5 partitions. And my midpoint tells me it's negative 0.67. Put it under the light, you guys can see a little bit better. Midpoint says it's negative 0.67. I'm feeling real good about this particular answer. But a lot of people, slack individuals, lucky they weren't my students, on this particular exam, they said use N to find part A to calculate the midpoint formula. You know what they did? They put M5 equals negative 0.67, no work. We know what they did. They went chunked it on their calculator and went, well, I declare victory, and put the answer in. We took extra points off for crap like that. No work means no credit. We'll take extra points off just making a look at crap like that. Write it down. Up here, we even the original directions say, write down the formulas. We want to see the work, not that you have a program on your calculator. I mean, that doesn't tell us anything about your mathematical abilities. Does that make sense? All right. Yeah. How do you input it? Okay, so just to remind you, I went to y equals, typed in my function, and then I second quit, and then I went and hit the program Riemann sum, and then but you have to put y equals first, and then your bounds, 0 to 1, and n equals 5. Remember, just to remind you on the program, if I was doing a Simpson's rule problem, the Riemann program does what to the Simpson's rule? Doubles the n value. So since I put n equals 5, this is actually Simpson's rule for n equals 10. Okay? So don't forget that in terms of your program. You know you're going to get one of these guys, so be prepared. The big old tank problem. Consider the tank shown at the right. It initially has a depth of 1. Excuse me. If the tank initially had a depth of 1 meter of kerosene at the bottom of the tank, how much work is done to pump all of the kerosene out of the tank to a level of 3 meters above the top of the tank? The density of kerosene is 810 kilograms per meter cubed. You may assume that only acceleration due to gravity is working on this problem at 9.8 meters per second squared, yada, yada, yada. Okay. First thing you got to do on any tank problem is you need to draw the cross section of that tank problem and put your coordinate axis. your coordinate axis sets up which integral you're going to use. And because my cross section is a triangle, I'm going to put my coordinate axis at the bottom. So this is 0. This thing is 2 meters tall. It's a width of 2 meters, which makes this 1, this -1, due to symmetry because I'm splitting it down the middle. This is my y-axis. Now, here's the big deal. Pay attention to this. And I'm going to go ahead and I'll throw in the dimension on this thing over here. This thing happens to be 3 meters long, and it's solid. Okay? So here we go. Now, most important, where are we supposed to dump? Where's the kerosene at and where we got to take it to? Quote, if the tank initially has a depth of 1 meter of kerosene, so over here at 1, this is where the kerosene is at. Does that make sense? That's 1. And wait a minute, we're not done yet. And we're supposed to pump all the kerosene out of the tank to a level of 3 meters above the top of the tank. The top of the tank is at 2. 3 meters above that makes it what? 5. 5 meters is my target. This is where I got to get my kerosene to. 3 meters above the top of the tank. Because I put my coordinates at the bottom, the top of the tank was at 2, 3 meters above that is 5. You got to put all this mutton stuff in there. Now, my formula for pump problems is work is equal to the sum of the delta force times the distance that you have to pump. Delta force is equal to, this would be kerosene weight, not water weight. So they're messing you up here, times the delta volume slice. What does kerosene weigh? Well, they gave me the density of it, which is 810, but what do you got to do to get weight in this wonderful metric system? Times 9.8 gravity. So this is my density times gravity is what I'm really doing here. Don't forget to do that. If it's water, you've got the numbers memorized. 9,800 for the metric system and 62.5 pounds per foot cubed for the English system. But if it's something else, we're either going to give it to you in the English system or in the metric system, we'll give you the density and you got to multiply it by gravity. Okay? Now you got to talk about your volume slice. The slice over here, I'm going to go somewhere where the water's at, and I'm going to make a little slice. And I'm going to pull that little slice out. When I pull that little slice out, it looks like this. It's either going to be one of two different shapes. It's either going to be disc shape or a little boxy shape. This one is not a disc. This one is a box. It is delta y tall. It has to be 3 meters long, because that's the length of the tank here. How wide is it? This is important. How wide is this tank? Very good. It is 2x. Because it's on a slant, when you move away from the y-axis, that's going to be x. So you've got x here, and you've got an x here, which makes that total distance 2x. Does that make sense? So the volume is going to be 2x times 3 times delta y, or your volume is going to be 6x delta y. Does that make sense? I'm going to clean up your delta force on this one because of that numbers you have to multiply by. So this is, I got 810 times 9.8 times 6, which gives me 47,628x delta y. Does that make sense? Now, so work is equal to the sum of that delta force times the distance that you've got to pump. So this is the sum of your delta force, which is your 47,628x delta y, times, here's the important part, where's the distance I have to pump? This slice we made was at an arbitrary y level, and I got to lift it to 5. It's a lift. That's work is all about lift, and it's a distance. Distance is right minus left or top minus bottom. This, we're lifting it, so it's top minus bottom. It's going to be what? 5 minus y. So now, coming over here, rewriting this in terms of an integral, work is equal to the integral 47,628 x times 5 minus y times dy. The summation turns into an integral. The delta y turns into a dy. And I got a problem. Classic problem. My tank's on a slant. I got a big old x in the middle of my integrating dy here. So I'm going to come up with this. The equation for edge of tank. The equation for the edge of the tank. It's going through the origin 0, 0, and it's going through this point 1, 2. So it's a line going through 0, 0 and the point 1, 2. So I need a slope, change in y, 2 minus 0 over change in x, 1 minus 0, which makes it 2. And I'm going to use the point slope formula, y minus y1 equals m times x minus x1. So y minus 0 equals 2 times x minus 0, or y equals 2x. But the purpose of the equation for the edge of the tank is so I can substitute it. So if y equals 2x, that means x is equal to y divided by 2. So work is equal to, pulling out my constant, 47,628 times the integral of x, but replace x with y divided by 2 times y minus 5 dy. Does that make sense? All I need now is my bounds. Where are my bounds? What's my bounds going to be? Where's the kerosene at? No, not 0 to 2. The kerosene's not up there at 2. 0 to 1. The kerosene is here. Between 0 and 1, you only integrate over where the liquid is, not where it's going to. That's where the 5 shows up at. Because it was up to 1 meter of kerosene in this thing, you integrate from 0 to 1 based upon my coordinate axis. Now, here's a question for you. So there's my answer right there. However, we're supposed to calculate this thing out, okay? Do you see anywhere on this problem where they say, use your calculator to integrate? No, you don't. Oh, that sucks for you. Which means, integrate it by hand. Don't get me wrong, I'm going to use my calculator to double check my answer, but I don't want to see it. It's not just about this. They actually wanted to see you lost points if you didn't show them the integration. The only time you're allowed to use your calculator to integrate is if they tell you in the problem, set it up and use your calculator to integrate, okay? But if they don't tell you use your calculator to integrate, this means it's got to be a pretty simple integral here. So here we go. I'm going to pull that 2 out front, so I'm going to clean up this guy. So that'll be 47,628 divided by 2 when I pull out that 2. That gives me, so work is equal to 23,814 times the integral of, and I'm going to distribute the y here, and that would give me 5y minus y squared dy from 0 to 1. That's now the integral cleaned up. This had all the parts into it as I substituted it. This cleaned it up. So now let's integrate it. So work is equal to 23,814 times. Integral of 5y is 5y squared divided by 2. Minus integral of y squared is y cubed over 3, evaluated from 0 to 1. According to the fundamental theorem of calculus, you plug in top minus plug in bottom. So that's 23,814 times 5 times 1 squared over 2 minus 1 cubed over 3. Minus, when I plug in 0, I love plugging in 0, so it pretty much gets 0 there. So I end up getting this. This is equal to 23,814 times 5 halves minus 1/3. And okay, now I'm going to go, this is definitely numbers now, so calculator. 23,814 times 5 halves minus 1/3. And I end up getting 51,597 watt. Don't forget your units. What's my units? 2 units would be acceptable, but typically 1 is what they're looking for. Joules, because this was the metric system. Also accepted Newton meters. Now the last thing I'm going to do here is I'm gonna go back and put this original problem that I set up on my calculator, just to double check him. So this will be math number 9, integral of, let's see here, I'll put my, in front of that, I'll insert the 47,628 times integral from 0 to 1 of x divided by 2, put parentheses around it better, parentheses x divided by 2, close parentheses, times 5 minus x, close parentheses, dx. And I'm just double checking my work to make sure 51,597 does show up. And now I'm real happy about my answer because my calculator confirmed my integration by part, my integration by doing it by hand. Does that make sense? Questions? Well, this looks like something you just had on your recent test. Recall that this is a gift. It's rare that they give this to you, but sometimes they do, sometimes they don't. Yeah, and the reason why they typically give this kind of stuff to you, but not on the multiple choice question, but on the free response, because if you don't know what e to the x is, there's no way you're going to ever answer these questions. So they'll at least give you a bone and show you the e to the x, but now you're supposed to use it. We love power series because they're easy to manipulate. So here we go. Recall that e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus yada, yada, yada. They even wrote down the summation formula. Sum as n goes from 0 to infinity of x to the n over n factorial for x is between negative infinity and infinity. Use the Maclaurin series for the expansion of e to the x in conjunction with algebra techniques to obtain a Maclaurin series for x squared times e to the negative x squared. All right, so we know this. You're going to build this guy. Show your work. E to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus ... which is equal to the sum as n goes from 0 to infinity of x to the n over n factorial. We're going to build x squared times e to the negative x squared. Okay? So the first thing I'm going to do, I got the e, I'm going to e to the negative x squared. So e to the negative x squared, what am I going to do? I'm going to replace x with negative x squared. This will be equal to 1 plus negative x squared plus negative x squared over 2 factorial plus negative x squared cubed. I'm sorry, this was squared over there. Over 3 factorial plus ... But they didn't say which form they wanted to write it in, so give it both of them. Equals the sum as n goes from 0 to infinity of replace x with negative x squared to the n over n. Now let's clean it up. This means that e to the negative x squared is going to be equal to 1 minus x squared plus, negative squared is positive, x to the 4th over 2 factorial. Negative cubed is back to negative, x to the 6th over 3 factorial plus ... Which would also be, when you clean this series up, this the sum as n goes from 0 to infinity, negative 1 to the n times x squared to the n over n factorial. And when you clean that up, power to a power you multiply. This is the sum as n goes from 0 to infinity of negative 1 to the n, x to the 2n divided by n factorial. This is the formula. These are the terms written down. Now, I've written out 4 of them, and that's typically good. 4 or 5, it's always good. But we're not done building yet. We built this guy. But what we want is we want x squared times e to the negative x squared. Okay? This would be equal to x squared times 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial plus ... which is equal to x squared times this series. The sum as n goes from 0 to infinity of negative 1 to the n, x to the 2n divided by n factorial. So I'm going to clean this up by distributing. So x squared times e to the negative x squared is equal to x squared minus x to the 4th plus x to the 6th over 2 factorial minus x to the, when you multiply, you add exponents, 8 over 3 factorial plus ... which is equal to, fold this guy back in here, this is the sum as n goes from 0 to infinity of negative 1 to the n. When you multiply, you add exponents. X squared times x to the 2n becomes x to the 2n plus 2 over n factorial. There's my series. Does that make sense? Have I lost you guys anywhere? Power series are easy to manipulate. Great for computer science and pure programming and stuff. That's why we focus on this, so we can really do a lot of computer science work with this stuff. How we turn our handheld add, subtract, multiply, divide machine calculators into the computers we have of today. Now, part B says this. Use the power series you found in part A, so don't screw up part A because we're relying on you actually getting the points for part B, to approximate the integral between 0 and 1 of x squared e to the negative x squared dx to within 0.01. Use the alternating series test to determine how many terms are required to get the answer to accurate within 0.01. Recall that, okay. You should give your answer to at least 4 decimal places or of a fraction. All right. So how many terms do I actually need to use on this thing? Well, all right, 2 ways I'm going to do this problem. All right, I'm going to show my accuracy type thing here. But, so to get my terms to within 0.01 here, all right, first off, you got to do this. We're talking about integrating from 0 to 1 of x squared e to the negative x squared dx. So the first thing I'm going to do is I'm just going to integrate from 0 to 1 of x squared e to the negative x squared dx. That would be just integrating from 0 to 1 of x squared minus x to the 4th plus x to the 6th over 2 factorial minus x to the 8th over 3 factorial plus dot 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 dx. Okay? Which gives you, here we go, x cubed over 3 minus x to the 5th over 5 plus x to the 7th over 7 times 2 factorial, careful of that, plus, let's see, minus x to the 9th over 9 times 3 factorial plus dot dot dot. So, these are my problems. Now, this thing is evaluated from 0 to 1. So, according to the fundamental theorem of calculus, you plug in top minus plug in bottom. Catch a pattern. This is 1 cubed over 3 minus 1 to the 5th over 5 plus 1 to the 7th over 7 times 2 factorial minus 1 to the 9th over 9 times 3 factorial plus dot 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 minus plugging in 0. You love doing that. Pretty much get 0 in your series. The question is this. I need to know what my accuracy needs to be. Okay? So, how many terms should we take this thing out to? Remember, your alternating series estimation theorem says that the remainder, which is the true sum minus the partial sum, is less or equal to b n plus 1. Because I can catch a pattern, I can write out as many terms as I need to do. The question is, how many terms do I need to write out? That's the question on this one. So, if I write 2 terms, catch a pattern. If I write out 2 terms, then your error, which is your R2, is going to be less or equal to B3. You with me? This is the alternating series estimation theorem. So if you do 2 terms, your error is 2 plus 1, which is B3. Your third term here is 1 over 7 times 2 factorial. 1 over 2 factorial is 2 times 7 is 2 times 7, which is 14. What is 14, 1 over 14? That is, on your calculator, 0.0714. Are you within this tolerance of 0.01? No. I need more than 2 terms. So try n equals 3. If I do 3 terms, then R3, your error is going to be less than or equal to 3 plus 1. So R2, R3. 3 plus 1 is B4. What's your 4th term here? Your fourth term is going to be 1 over 9 times 3 factorial. 3 factorial is 3 times 2, which is times 1, which is 6, times 9, which is 6 times 9, which is 54. And 1 divided by 54, just to show you what I'm doing here, 1 divided by 54 is 0.0185. Is that less than that 0.01 tolerance that we're required to have? No. Can't try 3. So probably 4 terms will do it for me. Well, what would the fourth term be? So this would be R4, which is B5. What would your B5? Now you need to catch a pattern on this thing. Catch a pattern on this one. It's see, there's your first term, second term, third term, fourth term. What's your fifth term going to be? It's going to be 1 to the what power? 3, 5, 7, 9, 11 over 11 times 4 factorial. You've got to catch a pattern on these things to be able to figure this out. So let's see, 4 factorial is 24. I'm going to do that with the calculator. 4 factorial is 4 times 3 times 2 times 1. That's 24 times 11. So it's 1 divided by 24 times 11, which is 0.0037. Am I within my tolerance now? Yes. So my answer is I got to have 4 terms. N equals 4 terms. 1, 2, 3, 4. I'm good to go. So I'm just going to go ahead and calculate this. And this would be, well, 1 cubed is 1. That'll be 1/3 minus 1/5 plus 1 divided by, what was that, 14? Minus, well, again, 1 divided by, what do we get here? I believe it was 54. And I get 0.1862433,862. This is the answer that will be within that tolerance. Now, honestly, if you did 5 terms, 6 terms, or 7 terms, you were within that tolerance range. But as long as N is 4 or more, you can have obviously more on this thing, 4 or more, you're within your tolerance range. Does that make sense? So you had to have at least 4 terms, and that's what we're grading. So we wrote down the answer. If you had 4 terms or 5 terms, you got credit for it, but you did have to tell me how many terms you need to at least take it out to, which was 4 or more. Does that make sense? So I got a question for you guys. Now that we've gone completely through 100%, and I still got 20 minutes before my 3-hour limit was up, and I gave these answers to you with deep explanations, so I could do a lot faster if I didn't have to explain it to people. My question is this: how would you have done on this exam? That's bad. Hopefully, when I go over it, most people tell me, yeah, that's great, Dr. Taylor. When you do it, I understand it completely. I should have made 100. And you're right, you should make 100. How did they do this particular semester? You would like to know? Class average on this particular exam was a 66 on that particular year, spring 2000, 66. And you saw some problems that had some issues that people, oh, I didn't need to know that, stuff like that. Number one, certain problems, students just left blank. Oh, I love when they leave them blank, as long as they're not my students. They're great because it's easy to grade, 0. But you guys are my students, you guys know something or other, never leave anything blank. Write it down. So the class average was 66. So which leads to the next question, which is, well, they curved this stuff? Well, I keep telling you guys, this final exam is based upon competition. What you really hope for in life is that you do awesome and everybody else bombs. That's really what you want done in life, okay? We do base it on competition. So with a class average of 66, we did have, 66 would have been about an average of a C range, and we coded that as about a 72. So we added up 4 points or 5 points up to the grade. So people that had an 85 on this exam, they bumped themselves up into the A range on this particular exam, because we do basically look at these grades in terms of competition. It goes from semester to semester. We give different exams each semester. Some semesters people do real well, and there is no quote-unquote curve or whatever the case may be. Other semesters, they really embarrassed themselves, and we kind of felt obligated to give you some points just to make yourself feel better about your life or something. But let's just hope we don't have to do that. But it's based upon competition. Go and study. You know this stuff. And if you've been in my class, I gave you guys a bunch of other final exams. Don't let this be the only final exam you guys go over. There's a lot more out there. Go hard and study. Where are the tests at? They are passed out in the back and they stop somewhere. So if you've got the test folders, please raise your hand and Joseph and Greg will help you find out where they're at.